गुड आफ्टरनून सर।
गुड आफ्टरनून।
आवाज जा रही है सर?
हाँ बिल्कुल बिल्कुल, इट्स ओके।
आवाज नहीं आ रही। हेलो, जा रहा। हेलो, आवाज जा रही है सर? सतीश
हाँ
सर?
हाँ, इट्स ओके।
ठीक 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 है सर, ठीक 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 ठीक। अभी हम लोग का सर टोटल रजिस्ट्रेशन दिखा रहा है 873।
873, हाँ, क्वाइट इनकरेजिंग।
हाँ, आज सुबह का। हाँ, बहुत बहुत मैनी बहुत इंकरेजिंग है सर। हम तो सोचे भी नहीं थे इतना होगा, है ना, बट ठीक है, बहुत बढ़िया हो गया, है ना।
हाँ, अच्छा है।
और बच्चों को यूट्यूब लिंक दे दिए हैं, बच्चे वहाँ से
हाँ, लाइव
देख
स्ट्रीम
रहे
हो
होंगे
रहा।
यूट्यूब
हाँ
लिंक से।
हाँ,
हाँ हाँ हाँ।
लाइव स्ट्रीम हो रहा है ना।
जी जी जी।
हम इसको देखते हैं मोबाइल में। रिकॉर्डिंग तो हो रहा है।
हाँ, रिकॉर्डिंग हो रहा है। हाँ, अब आप ज्वाइन कर सकते हैं।
ये जस्ती, मनोज।
जी 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 जी, बहुत बढ़िया सर, बहुत बढ़िया, बहुत अच्छा।
हाँ हाँ हाँ, देयर इज अ टाइम लैग। हाँ,
थोड़ा सा टाइम लैग होगा।
टाइम लैग है, थोड़ा इंटरफेरेंस होता है।
हाँ
इस आपका आवाज सुनाई दे।
ऐसा बात नहीं है कि सिर्फ तुम्ही से नहीं बनाया, किसी से।
हेलो डॉक्टर अंजुम, आपने ज्वाइन कर लिया?
मनोज सर।
हाँ हाँ सर, गुड आफ्टरनून। हाँ संजय सर, वेलकम। गुमला में है सर अभी?
हाँ हाँ,
अच्छा, ठीक है, घर पे। हाँ सर, गुड आफ्टरनून सभी को।
गुड आफ्टरनून सर, गुड आफ्टरनून।
गुड आफ्टरनून मनोज जी।
हाँ, गुड आफ्टरनून सुनील जी।
गुड आफ्टरनून सर।
गुड आफ्टरनून सभी को, सभी को।
सबको प्लीज कीजिए।
सुनील जी कहाँ
Sir,
है?
it's a milestone for Ranchi University.
गुड आफ्टरनून अंजुम, डॉक्टर
Good
अंजुम
afternoon.
महताब।
हाँ,
चलिए, तो हमारी फर्स्ट स्पीकर ज्वाइन कर चुके हैं, हम लोग शुरू करें सर।
गुड
सतीश
आफ्टरनून
सर,
डॉक्टर।
गुड आफ्टरनून सर।
सर हम लोग शुरू करें सतीश सर।
हाँ हाँ, लेट्स स्टार्ट।
हाँ, सभी से पहले आग्रह है कि अपना म्यूट कर लें अपनी आवाज को, माइक्रोफोन को। जो स्पीकर होंगे वही अपना माइक्रोफोन खोलेंगे, अदरवाइज इंटरफेरेंस होगा। As you all know, this is the national webinar on some advanced technology. Indian Association of Physics Teachers, Jharkhand Regional Council and Department of Physics, Ramlakhan Singh Yadav College, Ranchi, welcome you all participants. Special welcome to our guest speaker, Dr. Anjum Mahtab, Scientist SG, ISRO, Hyderabad, and Dr. Anil Kumar Nirala, Professor, Department of Physics, IIT ISM, Dhanbad. Till 11 a.m. this morning, a total of 873 participants have registered themselves for this particular webinar. You can imagine how huge number it is. They are university professors, retired professors, research scholars, PG students, UG students, as well as school students of class 11th and 12th. I welcome you all from the bottom of my heart. Before starting the formal lecture, a small announcement is here that after first talk, a feedback link will be shared in the chat box as well as in YouTube link. You all have to fill it up and submit. E-certificates will be given to those only who will fill up this feedback form, and this feedback form can be submitted only up to till 6:30 p.m. today only. Now I shall request Dr. Satish Chandra Gupta, President, Jharkhand Regional Council, RC20, to inaugurate the webinar by saying few words and welcoming our guests.
Thank
Dr.
you,
Satish
Dr.
sir.
Manoj. Thank you, Dr. Manoj. First of all, very, very good afternoon to all the participants who have registered their presence virtually. I think we all know about IAPT, Indian Association of Physics Teachers. It was founded in the year 1984 by a noted international physicist, Dr. Professor D.P. Khandelo. And though, as the name suggests, it is an association of teachers, I think it is more for the students and it is catering more to the needs of the physics students. Not only physics, you must know that IFPT has been conducting many examinations. One of them is the National Standard Examination, NSC. That is the first stage of International Olympiad. Now, these NSC, the National Standard Examinations, they are conducted in physics as well as chemistry, biology, astronomy. And this is the first stage of International Olympiad. And the next levels are conducted by Homi Bhabha Center of Examination, HBSC. So it also conducts graduate level examinations, NGP, as well as junior science talent search examination. Now, this IAPT is engaged round the year, relentlessly, for promotion of physics teaching and testing in India and also out of India. Today, we have assembled here for a national webinar on some advances of physics in association with Ramlakhan Singh Yadav College under the aegis of IAPT. First of all, I would like to say that Dr. Preeti D. Minch, Associate Professor there, owes all acclamations for organizing this webinar. Thank you, Dr. Preeti. Wish a very successful webinar for all of us. Now, today's speakers, as Dr. Manoj told you, are Dr. Anjum Mehtab, Scientist, SG, National Remote Sensing Center. She will talk on satellite remote sensing technology and its application. Now, the second resource person is Professor Dr. Anil Kumar Nirala from IIT ISM Dhanbad, and his topic will be 3D imaging. I feel great pleasure when welcoming you all, the speakers, the teachers, the students, and I think the talks given by the resource persons or guest speakers will benefit all of us. I take this opportunity also to thank all the students and teachers who have assembled here virtually for this international webinar. As Dr. Manoj has told you that this webinar is streaming live on YouTube also, and I am presently viewing it also on my mobile phone. I once again thank each other and every person who have been here, who have been instrumental directly or indirectly with organizing the webinar. Thank you. Thank you again.
Thank you, Dr. Satish. Now we will start our talk. But before the first talk, I would like to introduce Dr. Anjum Mahtab, our first speaker. Dr. Anjum Mahtab, scientist, SG, did her master's in physics from Banaras Hindu University, Varanasi, in the year 1993. She joined Space Application Center, ISRO, Ahmedabad in 1995, and while in service, did her PhD in physics in year 2008. She has worked in the field of photogrammetry, GIS, GPS, atmospheric correction, interferometry, agriculture, and satellite sensor parameter related studies using remote sensing data. In 2007, she came to National Remote Sensing Center, Hyderabad. She has more than 10 years experience of teaching as part of ISRO's capacity building and outreach activities program. Presently, she is involved in the field of rural development using satellite and field observations for various industry and ministry projects. She has more than 30 research papers in various national and international journals and conferences proceedings to her credit. She is recipient of prestigious DST award for attending meeting with Nobel laureates in physics in Linden, Germany in the year 2001. Now, I request Dr. Anjum Mahtab to please share your screen and start your presentation. Dr. Anjum.
Yeah, thank you, Dr. Manoj. A good afternoon to all of you. And I'm really very grateful to Dr. Manoj and the Society for Physics who have invited me for this lecture. And I'm really something like after 25 years, in between I have visited my university back, but not the physics department. I have gone to ITBSU for some project work and some lectures also. But it's very nice feeling after almost 25 years. I'm going back to my physics seniors and my peers and my junior students, and I'll be addressing them. So it's like I'm coming back to my subject. I did my MSc, as Dr. Manoj has told, and now I'm working in the field of remote sensing. So I'll start my talk. I'll be sharing my slides. Dr. Manoj, you are getting the slides?
No, I am not getting the slide. Please.
Just. Host has to enable attendee screen sharing. Manoj, you have to do, I think.
Just a minute. Just a minute.
Manoj, I am not getting your audio. You are telling some. Now I am getting. Now I am getting. Yes.
नीचे स्क्रीन शेयर लिखा है मैडम नीचे
हाँ that
बार में
that I'm trying, but it says host disabled attendee screen sharing. You have to go to settings and then enable.
Is it working now?
No, still it says host disabled attendee screen sharing. What has to be done? You have to go to settings. Go to settings, then check the box saying enable. Check the box which says enable screen share. Screen share. In the settings there will be an option. In the settings there will be an option. वीडियो के लिए वीडियो तो है आपका चेहरा तो आ रहा है हाँ वीडियो इसका स्क्रीन शेयर इज नॉट कमिंग
सर ग्रीन कलर का स्क्रीन शेयर होगा उसी को नीचे क्लिक कीजिए
हाँ नहीं मैं कर रही हूँ ग्रीन कलर का स्क्रीन शेयर जैसे ही दबाती हूँ वो कह रहा है होस्ट डिसेबल्ड अटेंडी स्क्रीन शेयरिंग
मनोज सर के थ्रू ही होगा मनोज सर
हाँ I think Manoj only has to do yes the host has to do the host
यस जो होस्ट है वही करेंगे
सर एक्चुअली आप डिसेबल कर
मैं भी शो कर रहा हूँ देख रहा हूँ नहीं हो पा रहा
हाँ सर मनोज सर उसको इनेबल करेंगे तो हो जाएगा डिसेबल कर दीजिए
हाँ
सेटिंग में ऑप्शन है सर मनोज सर
Just I'm trying, it will work.
Okay, sir. Okay.
Now, Anjum, please.
Check it up. It says. I think yes. I think now it is enabled. Just a minute.
Yes. Okay.
Yeah.
Now it's working.
I'm giving you people have to tell.
Yes,
it's working, sir.
It's working.
Yeah, getting.
Okay, okay. The screen.
You people are getting?
Yes,
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 we
yes.
are getting.
Yes, yes. Everyone is seeing.
Manoj, Manoj,
Now,
please request the participants to mute their mic.
uh,
There is
I
unnecessary
am
disturbance.
requesting once again all the participants please mute your mic. Only Dr. Anju Mahtab will be able to speak. Otherwise, there will be
Whether
interference.
whether you people are seeing the first slide, Indian space program.
Yes, yes, we are
Yes,
seeing.
yes, yes, we are seeing.
Okay, okay, okay. So we will start this presentation with the vision of with the vision of the father of Indian space program, Dr. Vikram Ambalal Sarabhai, that we are convinced that if we are to play a meaningful role nationally and in the community of nations, we must be second to none in the application of advanced technologies to the real problems of man and society. So when the Indian space program was formed, and when they were planning for this program, the main objective was that all the technology, all the advanced technology, whatever we are going to use and we are going to plan in future, it should be able to help the real, or it should be able to solve the real problems of man and the society. So that was the thing in his mind, and it has been translated in a very beautiful program. I'll try to go through them. So, if you see the various dimensions of the Indian space program, in the center you see the societal and development applications are at the center of it. So, whether we are talking of INSAT-based programs or GSAT or Indian remote sensing IRS programs, we have the university working on space sciences, we have the physical research lab, all these things, whether we are talking of launch vehicles or we are talking of satellites, everything, if all the technologies should converge and should work towards the societal and development applications. That was the uh, idea with which we started, and still we follow that. So that is why I have written his vision was to harness the space technology for national development while pursuing space science research. So we are not anywhere lagging behind in space research also, as well as the planetary explorations. You people know very well that we had a very successful Mars mission, and then we had one mission for Chandrayaan 1, and then in Chandrayaan 2 there were some initial hiccups, and then still that mission, the other part of the mission is working. So even though we believe in pursuing very focused space science research and planetary exploration, we still are very down to earth and very and believe in the basic research which should help the society and the development of that society. So we will talk some few basics of the remote sensing. Basically, right now we are doing remote sensing. I am sitting in a remote place of Hyderabad and trying to connect with what Dr. Manoj told, some 800 plus people who are spread maybe in the various parts of Jharkhand, and we are trying to reach each other without being actually in physical contact with each other. That is the definition of remote sensing. So it is basically the process of obtaining the information about the objects, about any phenomena or any area, through the analysis of the data which has been acquired by a device which is not in physical contact with that particular phenomena or object or area. So if we see, God has given us sun, which is the continuous source of energy for our life,
We are not getting the voice of Dr. Anju Mehta.
The slide seems to have paused and we are not getting the voice of Dr. Mehtab. Some glitch.
Yes,
Oh,
yes,
it
yes.
has come
Now,
back. Oh,
sir, whether it has come back,
yeah, the
a
sound
voice
has
you are
come back.
getting?
Yeah, yes, sound has come back. Oh, yes, sound has come
The
back.
PP. Yeah, yeah, yeah.
And we are with the slide. What is remote sensing?
Yeah, yeah.
You can continue, Dr.
Ha,
Mehta.
sir.
Okay.
Yeah, yeah, sure, sir. After receiving the data at the Sharnagar and doing some basic processing, the data is given to the number of users for their further analysis and use in the various applications, which we will be discussing in the further part of the presentation. So, what are the advantages of uh, remote sensing? See, the best part of it is you get the bird's eye view of the area what you are viewing, which is known as the synoptic view also, because you are at a very high distance, very large distance, some 900 kilometers from the surface of the Earth, and from there you are viewing or taking the pictures, recording the energy which is reflected from the various targets. So it gives you a synoptic view. Okay. The second part is it has the ability to provide you the data of inaccessible areas. So inside a forest or in the middle of the ocean, or if some disaster has taken place, how to it is very difficult to reach that area at that moment. But if you have a remote sensing data, you will be able to capture the images of that area, which you can process and use it for further analysis. So all the inaccessible areas you are able to provide the satellite data. Then it gives you a global coverage. Any part of the globe, when you are there, you can get the data of satellite data of that area. It's a permanent record. It is not going to change. Okay, that permanent record you can use it as a pre of pre data of some phenomena which has happened now, and afterwards also you can use it as a record. Okay, as a proof, as an evidence that this phenomena has happened. I think somebody's or mic is on. We are getting a lot of noise. Yeah, I think now it is.
डॉक्टर सी ठाकुर शायद आपका माइक ऑन है, उसको ऑफ कर लीजिए.
Yeah, yeah. Now it is better. Yeah, thank you so much. Then we have the repetitive coverage of the same area that helps us to study on the temporal scale. Now, what is the advantage of this? Say, for example, see, this is the November, October month. Na? Our Kharif crop, which is mostly the rice crop, which is there in the field, is getting to be harvested. Okay, and after that, we will start for the Rabi crop or the winter crop. So, if I talk about a temporally active phenomena like the growth of a crop, so I will take a picture in June, in July, in August, in September, in October. I can start with the sowing of rice in a particular area. I can see how it is growing in the subsequent months, and then how till it reaches senescence or it reaches the maturity until it is cut, it is harvested in the fields. We will be able to monitor such kind of dynamic phenomena which changes every month or every 15 days, something like that. Another example is like, say for example, a disaster happens. Say for example, present last 2 days Hyderabad has witnessed lot of rains. Okay, so if I want to see how much area is inundated in a city, in a rural area, in any area, urban, rural, anywhere, how much area is inundated because of the floods, in which direction. Now, okay, after 2 days, if I will take another picture, I can see in which direction the water is moving, from which part of the city it has been cleared. And say, for example, another disaster I will take, a forest fire has happened. See, forest fire moves very fast if the winds are fast. So in which direction the fire is moving? So I need something like every 12 hourly or everyday picture of the same area. Or some cyclone is coming, so every hourly data will be adding some information to the data what I am having presently. So that kind of studies, which are very dynamic on temporal scale, they require very the repetitive coverage of the same area. But whereas they study something like how the city of Ranchi has grown in last 10 years, if I want to study, I need not take every 15 days or a month data. I should take something like a decadal data or a 5-year difference data. So depending on the type of application you are planning, the type of information you need, you have to choose your remote sensing data. If it is very dynamic in nature, you have to choose 15 days or 10 days or 2 days even, or hourly basis also. Okay. Whereas if it is not that dynamic, you have to choose something like every 2 years or every 5 or every 10 years. So it gives you a repetitive coverage of the same area. And then it helps you to derive precise information. It's an unbiased result. Nobody has any bias while taking the pictures. It has taken an unbiased. So this kind of result, the results of the remote sensing data have been used as evidence for, say, for example, in forest encroachment type of studies. They have been used and they have been accepted by the court of law, where they have used this as an evidence that yes, before encroachment this area was under this kind of forest, restricted forest, or uh, protected forest type of thing, and after this encroachment this much area has been disturbed. Okay, so it gives you an unbiased result. So these are some of the advantages which I feel are very important as far as remote sensing data is concerned. Now, remote sensing is of two types. The remote sensing, which is done with the use of the sun's energy, sun's electromagnetic energy, is known as the passive remote sensing. It is something like you are you are taking a photograph in with your camera, with your photograph camera in the day sunlight. You don't use flash. No? You take just the natural light, and reflected light is recorded by your camera. So that is an example of passive remote sensing. Whereas in active remote sensing, we send our own energy and we receive back that same energy. For example, when you take the photograph during night, you use the flashlight. You provide, your camera provides the light, which will be reflected by the objects, and the photograph is taken. So that kind of remote sensing is known as active remote sensing. So we have satellite sensors which work on the principle of active remote sensing as well as on the principle of passive remote sensing. Okay, so basically they record the reflected and the emitted energy from the various targets. The target can be atmosphere, the target can be land, the target can be water, the target can be ocean, the target can be something like the various layers of atmosphere also. Okay, so and obviously the other planetary objects, if we are interested, those objects. So the target could be anything, but recording this kind of energy which is reflected and or emitted by the various objects gives you the remote, or helps you to generate the remote sensing images. Okay, what is the source of this thing? Is nothing but our electromagnetic radiation, where the electric and magnetic fields are perpendicular to each other, and in the third direction the wave is moving with the velocity of light. So we are recording the electromagnetic radiation in the form of the satellite images. Now let's see the electromagnetic. Uh, is there some problem?
No, you can.
Okay, okay, okay. Okay. So let's see the electromagnetic spectrum. For the group of physicists, it is very easy and to talk with you people. So you see, we have between zero point 0.4 to zero point 0.7 micrometer, our visible wavelength band. Then we have the infrareds, and in the higher wavelength side, from left to right, if you move, we have the microwaves, we have the radio waves also. Okay, so the mostly the remote sensing, if we talk about, it's is concerned within the region of visible, the infrared bands, and in the microwave region, basically in these three regions. Whereas many experimental part of remote sensing, we use the ultraviolet region also, and in between two regions also many times the experiments are conducted. But the basic region where we do the remote sensing is basically these visible, near infrared, the after near infrared, our short wave infrared, the mid wave infrared, all these various spectral bands are decided on the basis of these bands and on the interaction of these bands with the various land cover targets. See, if you see the visible and the near infrared band as well as the short wave also, you you see that they basically exhibit the reflective properties of the objects. Okay, so whatever energy you are receiving at the sensor level or at the satellite level, sensor level, it is because of the reflective properties of the target. Okay, the interaction is reflection basically. Whereas when you go beyond short wave infrared, in the long wave and thermal infrared, it is basically the absorptive properties of the target, which basically manifest in the form of their interaction with the various wavelength bands. And in the microwave region, that means in the larger wavelength region, see the values which are written in the bracket, they represent the wavelength, and the values in gigahertz, they represent the frequency. They are one and the same, but I have given the frequency as well as the wavelengths. So in the microwave region, when the wavelength is of the order of say 100 centimeters or 15 centimeters, from micrometer you have come down to centimeter and millimeter level, you can understand how large this wavelength is. So this wavelength won't be interacting with the chemical properties of the object, like say the visible, our visible and the near infrared, they say for example an interaction with the agriculture, if I talk about the leaf, if we talk, it will be interacting with the chlorophyll, with the mesophyll tissues and all this, that. Whereas the microwaves, they won't be seeing all this because they are the larger wavelengths, no? So they will be seeing the orientation of the leaves, so they give an additional dimension to the results what we see from the microwave data. So optical, if you talk, or in optical, the visible has a unique application, the infrared and other bands have other type of application, and microwaves have another type of application. So all these variety of bands are used to carry out a number of application activities, which I will be discussing. You see this image. Okay, I'll tell since I know this area, I'll tell you it belongs to district Kakinada in Andhra Pradesh. Okay, all of you are able to see the cursor moving now. Okay, so this is part of ocean. Okay, this is Bay of Bengal. Okay, this is a thin strip, okay, which goes like this, and here you are seeing the backwaters, whatever here you are seeing. This is a portion, this is the portion of the land just next to the sea, and here these are the mangrove forests. Okay, in the backwaters, like you must be, people must be knowing, no? Our backwaters in West Bengal. Okay, so a similar way here also you see these are the backwaters, and here you have the mangrove forest. Whereas here different type of agriculture is there. See, I know this area, that is why I'm telling you. Otherwise, nobody can tell just like that. Okay, here another type of some agriculture is there, but it's not very what I should say, very healthy agriculture. Okay, and here some water bodies there. Okay, you see some river is going and flowing like this. Sorry. Okay, in this picture that river is not very clear. Now you come to this picture, the NIR band picture. Okay, you see the river is so clear. I need not tell you, but you can see yourself that the river is going and flowing into the ocean. Okay, but here you see the river is mixing with the background, whatever is there. So this is the, with blue spectral band, you have taken this data. Okay, I want to spend few minutes on these slides so that if you people will understand this, the further slides, it will be much easier for you people, and it will be more enjoyable for you people. Okay, so you see here the turbidity in the ocean, whatever is there in backwaters as well as in the ocean part of also, you can see you are able to appreciate the changes in turbidity. Okay, here also you are able to see some of the changes, but as you are moving from blue to green to red to NIR, you see the variability in water is reducing. Okay, so you can conclude that blue and green color will be giving you some information on the water quality. Whereas you see that in the NIR band, everything is absorbed. So the water and land is very clear. Now we will see one simple reflected energy curve with the wavelength. You see, this is on this side I have plotted reflectance, and on this side I have plotted wavelength. Okay, you see if the water is shallow, so zero point 0.4 blue I am starting, zero point 0.5 is green, zero point 0.6 is red. So because of the whatever sediments or this thing is there, you will get some reflection from the water, and then after red, after zero point 0.6, you see it is falling. Okay, so absorption is taking place, and after you cross this NIR point beyond zero point 0.7, zero point 0.8 or so, the reflection is very, very small. Okay, so this dark blue line, if you see, this is of the pure water, whereas this light blue line, this tells you the shallow water or the water which has lot of sediment. So this, why the two type of water is different, because this is clear water or deep water, you don't get reflected energy from the bottom of the water or the sediments, whereas here the bottom is, it is not that deep. Okay, it is shallow, so you are getting the reflected energy from the bottom as well as you are getting energy from the sediments, reflected energy. Okay, so ideally speaking, water when you come to an IR region should become almost zero, because there is full absorption by the water. Okay, so you can appreciate this fact that if you have to study the turbidity in water or the water quality related applications, you should choose blue and green. Whereas for differentiating between water and land, you should go for red is not that very good, but NIR is beautiful. You can see the distinction between the water and the land here also, and here also. So whether ocean or river water or backwater, all water will look similar in NIR region, and it's very distinct. There is a distinct demarcation between the land and water in NIR. Whereas if you want to study the water turbidity, water stress related studies and all that, you should use the bands blue and green. Okay, now we will see the another feature of vegetation. Okay, you see in blue it is less, in green it has increased because of the chlorophyll reflection, in red it has reduced because again chlorophyll gets absorbed by the red light. In NIR, if you come, you see a very high reflected energy. You see around 45 or 50 counts it is giving. Okay, see, reflectance is not exactly the reflected energy. Reflectance is the reflected energy divided by the incident energy converted to percentage. That is why it is always represented in percent form. So it is known as reflectance. Okay, which is a ratio of the reflected divided by the incident. So you see the so you see the vegetation is giving very high reflected energy in the NIR region, and then it is like that. And then when you go to MIR and after that SWIR and all, you see that there is a dip. So this is the absorption dip. So this is also very useful in remote sensing. We use these bands for different kind of studies where the crop is in stress. Okay, so it's, since the crop is having less water, So it will be giving more reflected energy than the crop which is healthy, which is having more water. So it will be getting absorbed. So the water is getting absorbed. So it will be showing less reflectance. So using the change in the reflectance, also one can distinguish between varieties of crops, between the stressed and the normal crops. Okay. So we'll go back to this slide. So you can see that the different bands have different reflected energy or absorbed energy. That is why the all the four pictures, they look different. Okay, here also a small portion of that has been taken. So you see blue band, you are able to see the water. In green also you are able to see the changes, because it's a small image, you may not be able to appreciate. But here in the NIR region, the water and land boundary is very distinct. And another beautiful thing, you see that 2 is vegetation. That means this dark patch you are seeing here is the vegetation patch. Okay, so in green it is less dark than in red, because in green the chlorophyll is reflecting, whereas in red the chlorophyll is absorbed by the red light and green is absorbed by the red light. And in the NIR region, it is reflecting very high. You can see here that 40-45%, 50%. If it is healthy forest canopy, you may get up to 50%, 60% also. Okay, see, vegetation doesn't mean only crop. Vegetation means any kind of plantation also, crops also, forest also. Okay, so here you see the reflectance is high. That is why this patch is looking white, bright in color. Okay, now what we do, if we are interested in blue energy, we keep the blue. Otherwise, we take the green, red and NIR band and give the red band of the NIR band of the spectral band of the sensor to the red color band of the computer. Okay, green to the NIR band to the red band of the computer, red band to the green band of the computer, and green band to the blue color band of the computer. Okay, and then what kind of image we get is will be looking something like this. So what is the beauty of this image, which is known as false color composite, is you have whatever is high in NIR will be looking red to you, because you have given NIR as red color to the red color gun of the computer. That is why it is seen as red. Okay, so this is known as false color composite, because you are not giving excuse anybody having any confusion.
No, please.
Okay, so we'll continue. So because NIR band has been given to the red color gun of the computer, it is showing red color. Okay, and hence you will see all vegetation, irrespective of what type of vegetation, always in red color. Okay, if it is a false color composite, but if it's a true color composite, you will give blue to blue, green to green, red to red. Okay, then you will be seeing what exactly it is there on the ground. Okay, vegetation will not look black, but it's a small image, it has not come out properly, but we will see the normal FCC of this Kakinada image. You can see whatever agriculture or whatever vegetation is there in this area is seen in bright red, which is healthy. Okay, you can see the dotted pink spots also, na? Here also, here also. This may be the spread kind of vegetation. Okay, some scrub land is there, or say some crop has been grown but it has not come up properly. Okay, but you see here the mangrove forest. This looks very red. In comparison to this red also, this looks much red, because it's a forest. It has very high reflectance. Okay, and the water body also, you can see very clearly the sand portion in the river, which is coming and flowing into the ocean, and near the ocean, the beach part of it. Okay, you see the white sand, no? Very, because sand reflects very high in all the bands. That is why always sand will be seen as very bright on the satellite imagery. Okay, now we will see the parameters which define a satellite imagery. Okay, so see, for example, in physics, what is the SI unit for weight, or what is the SI unit for time? Like that, for the satellite remote sensing data, also we have some units or the parameters to define them. So the parameters which define the satellite remote sensing data, they are four in number: the spatial resolution, spectral, radiometric, and temporal. And all these parameters are specific to a mission. So if I say IRS 1C, if I am giving some number, it will be fixed till the mission is over. You cannot change in between. Before sending, only whatever changes can happen, it will be reflected there. Okay, we'll try to understand these things. See, this is a part of Hyderabad city. This is the Hussain Sagar Lake. Okay, this is the Hussain Sagar Lake. That black. Now you people can understand that whatever black you are seeing on the image is the water. Okay, whatever red you are seeing, these are all false color composite. Whatever red you are seeing is a kind of vegetation. Could be crop, could be spread vegetation or plantation. This gray cyan color, what you are seeing, is the city part of it. Okay, so you see here, the spatial resolution of this camera is 72 meter. Okay, 72 meter means what? The An area of 72 by 72 meter has been captured and written as a dot on this image, on this picture. Okay, so a 72 meter by 72 meter information has been captured and represents the smallest unit of this image. Okay, that smallest unit is known as pixel, the picture element, pixel, pixel. Okay, we say, what is the pixel size? This is the way we ask, no? This mission, what is the pixel size of it? Pixel size means the spatial resolution. See, when you buy a camera, you see now how many dots per mm or per centimeter, like that. So how good your camera is, this is one of the specifications of your camera. So this will be showing you a 72 meter by 72 meter area on one dot. Now here you have reduced that area. You have just divided it by 2, 36 meter by 36 meter. So you can see, in comparison to this image, the clarity here has increased. Okay, still you are not able to make out many of the things in this image also. Okay, but when you come to this 23 meter image, you are very well able to see a aeroplane strip here. All are able to see. I hope you people are able to see.
Yes, yes,
Otherwise,
yes.
I will.
It is visible.
I
It
will.
is visible. It is visible.
So, since I'm telling you, you can see that it's a straight strip. Okay, and one aligned strip is also there. This is basically the earlier Begumpet airport of Hyderabad, which was within the city. Okay, and whatever white line you are seeing surrounding the Hussain Sagar Lake is the Necklace Road. If some of you have visited Hyderabad, you people must have gone to see the Necklace Road. Okay, and this is a man-made lake, and here one dot you people might be seeing. This is one Buddha statue is there within that lake. Okay, so even that Buddha statue has been picked up in this 23 meter data, which has not been picked up by this 36 meter or a 72 meter data. Okay, a spatial resolution of 23 meter data means if two objects are separated with a difference of 23 meter, you will be seeing them as two distinct objects. It doesn't mean if the objects are of 23 meter size, you will be seeing them. No. If the distance between the two is 23 meters, you will be seeing them as two distinct objects. Okay, so this is the definition of. So higher the spatial, rather the smaller the spatial resolution, better will be the clarity in the image. So if I see this same area with a 5 meter data or a 1 meter data, I'll be seeing the roads on the Hyderabad. Okay, so we'll see the examples which I'll be showing. Okay, quickly we'll go through the okay, this example also tells the spatial resolution. See, I am seeing our Rashtrapati Bhavan with a 1 meter data. This image, you see, even you are able to see the trees in the Rashtrapati Bhavan. You are able to see the road also, whatever is there, the nearby construction, everything. The central part of it you are able to see. Same part of it I am seeing with the 6-meter resolution. Okay, you can see it looks little hazy, a little defocused. Why? Because this 1 meter by 1 meter, 6 by 6 pixels, full information you are clubbing into a single pixel of this thing. So here the distinction becomes little hazy. So higher the spatial resolution, better is the clarity. Higher means smaller the number. Okay. So we will see examples. Now this is the concept of spectral resolution. See, you can see in single bands, blue band one band, green one band, and red one band. So it's a color film. Okay, multispectral data. Whereas if you see a single band, 0.4 to 0.7, you will get one band only, but it will be having a higher bandwidth. It will be having higher energy. You are recording more energy in this band, whereas you are recording less energy in these bands. Okay, so this black and white film is known as a panchromatic band, whereas this color film is known as a multispectral data. Both type of data sets have got different application. We'll see some of this. Just before going to the examples, one more resolution, which is the radiometric resolution. See, you are recording all your data in a digital format, so it will be binary. Okay, so base 2 will be used. So if it's a 2-bit image, means 2 to the power 2, 4 levels. So you can see this data, this left side wala image, in 4 levels only. Whereas this is an 8-bit image. That means 2 to the power 8. So 256 levels. So you can see 256 different levels of the reflected energy from the various targets. So higher the radiometric resolution, more will be the clarity in the image. But you cannot carry that much data on board those satellites. Okay, so you have to have a optimum range of spatial resolution, spectral resolution, and radiometric resolution. Okay, then temporal resolution, the examples are, say, every 3 hours you are taking a picture. So if your temporal frequency is that high, see, this kind of data is useful for meteorological purposes. Your Mausam Vibhag, IMD and all will be using this kind of data. So what are the meteorological parameters, how they are changing, how clouds are moving, what is the precipitation, all such kind of information is available, can be seen, but it will be available at a very coarse level, 1 kilometer, 10 kilometer, like that. Okay, here the pixel size will be as coarse as 10 kilometer or 50 kilometer. Whereas this is a seasonal images. This is this state of Punjab, and you are observing what type of crops are sown in the various seasons, and you can see that in various seasons the cropping pattern is changing. Now you people are comfortable with the red color, which shows some kind of vegetation, and this gray green tells you the land which is not occupied by this kind of vegetation, which is free or having some different kind of scrub land or something like that. Okay, then annually also you can see the same area. Say for example, you have done some, you have carried out some procedure on that area. So how it is changing over the years, and these are the decadal changes. In 1972 there was no check dam here on the water body. Here you have made one dam, you have conserved the water, and in 2002 you are trying to see the long term changes. So it depends on what kind of application you are doing. Okay, now we will see some examples. See, in Athens, 2004 Olympic Games were scheduled. Okay, 2001 their that sports village used to look like this. Okay, then they thought, no, we will renovate this sports village. So they have gone for renovation. You see, in 2003, after 2 years, after it has been decided that Olympics will be there, you can see the things have been getting renovated. Okay, the rubbles, that open land you are able to see. Whatever was there here in 2001 is not seen in
Your sound
2000.
is not coming.
Okay. Now it is better. Hello.
No,
And now it is
it's not working.
not working. Okay. हाँ वो आवाज नहीं जा रही कौन है वीडियो ऑन
We are getting.
you are unmute her.
We can hear the voice, ma'am. I think.
Okay.
That is the
Okay.
problem.
Well. Yeah. So now you can see in the 2004 the new complex which has been made, and because the new structure has been made, you can see the clarity in the structures also, and the changes which has happened. So remote sensing data can be used for change detection type of studies. They are being used, and as evidence also they can be used. Okay, now just briefly I wanted to tell you people that since we are using multi-band images, na? We discussed blue band, green band, red, NIR. So we use different type of filters to take these images, and the images are being collected, and then different images are being made. Now this is an example of panchromatic data. Our BARC in Mumbai can be seen. You can see the structure of the buildings. You can even count the floors also. Okay, you can see the roads which are near the main building. Then you can see the greenery which is there. Okay, the trees which are there. You can see the clarity in the image. Okay, lot many things. The trees which are just on the other side of the road also, you can as such count those trees. So much clear data is there. Okay, now we will see one multispectral data. This is Nampally station, Hyderabad. Okay, you can see the trains, the coach of the trains. You can see the bridge, railway bridge. Okay, then the nearby buildings, whatever are there, the sheds and all can be seen. The parking lot of the railway station can be seen, and these are the nearby roads. You can see the bus moving and the other smaller vehicles moving. Okay, so this is a high resolution multispectral data of a QuickBird satellite, and we are getting the details from that satellite. Okay, high resolution, high spatial resolution data is very useful for urban infrastructure, urban change related studies, urban road related studies. It's very useful. Sorry. You can see the stadium which is there, the new stadium. No, sorry, it is not new. It is also now quite old, but the other part of the stadium, the neighboring second stadium. Then you can see the crossroads, the Choraha part of it, and the roads which are there, the bridges which are there on the roads. Then you can see the garden which is nearby this Nampally station. Okay, and obviously the moving vehicles, the buses moving, the smaller vehicles, all those things are there. Now this is a part of Mumbai. Okay, Chowpatty beach, most of you must have seen. Since the beach has sand which reflects very high in all the bands, you are seeing a very bright return, a very high return from that part of the beach. And this is your that marine drive, and you can see the changes in the water near the shore also. Here the other things, boats and all, smaller boats and all, whatever is parked. So you can get a very clear picture, a very detailed picture of the city. Now this is so this was the multispectral data. You can see part of Mumbai IRS P6. IRS means our own satellite, Indian Remote Sensing Satellite. Okay, it's a multispectral image. This is a panchromatic image. Again, IRS sensor has been used, but it's a panchromatic sensor. So you can see the Mumbai airport. You can see the parked planes here. You can see the runway, the markings on the runway. Then you can zoom a portion of the airport and you can see the things which are there. If such kind of information is available, and if we have the thermal data along with this kind of data, we can use that kind of data to exactly tell that whether this plane has just been parked or it is about to start because of the temperature changes with respect to this plane and the background of the plane, which is basically used for the strategic purpose by our military and other people. So for a strategic purpose, that kind of information can be generated. Okay, now this is a part of Abu Dhabi. Again, we are seeing a quick bird image. Quick bird is basically a American sensor, which has a 2.44 meter. This is the spatial resolution, multispectral data, and a panchromatic sensor of 61 centimeter. Now, here what we have done, we have combined the two camera data. Okay, 2.44 multispectral and 61 pan data. So you will have clarity coming from the pan data and the color coming from the multispectral data. Even you can see the high tension wires which are going now. You see the clarity in the data. Even the beach portion part of it, the waves which are coming and the vehicles which are parked and all. So much of detail. You can see one beautiful thing, the shadows of the structure. If you know the exact time of the pass of the sensor, you can as such use sun angle formula to calculate the what time of the day it was and what is the height of the structure also. Okay, depending on the time of the pass, you can calculate the height of the structures also using the shadows. Okay, this is another example where where we are seeing the Australia airport. The vehicles are parked and the aircraft which is coming on the airstrip. Okay, the parked vehicles, other things. Okay, this is one of the islands in Indonesia. Uh, the change detection, whatever I have told you, no? This is another example of change detection. This is before that tsunami when it came, 12 December. You can see the various buildings, the connecting roads and all. And after tsunami, what was the devastation that has taken place? So this kind of images tell us the devastation which has taken place, extent of devastation, and which is the area which should be given priority for rehabilitation purpose. So this kind of data is very useful from that point of view. Okay, then these are some beautiful images I wanted to show you people. This is your that Palm Island of Abu Dhabi or Dubai, where Shah Rukh Khan has a flat. I don't have. Oh. So you can see the difference of water and land so clearly seen. Okay, this is the multispectral data where we are seeing the Myanmar, the backwaters near the Myanmar coast. The blue dots, what we are seeing here, they are the Maldive Islands. Okay, and white dots, what you are seeing, they are the clouds which have come because it's an optical data. So clouds, effect of clouds will always be there. This is part of Washington City. Okay, so remote sensing is a science of taking pictures. Can we say so? And a picture is obviously equal to 1,000 words. So a picture is not as such a picture, it's a wealth of information which can be used in a number of applications. So now after telling you the brief basics of remote sensing, I am going to show you some of the things which how they look on the satellite images, and then we will come to the actual application. So agriculture, which looks something like this in on ground, will look something like this on the satellite image. Okay, because these are the fields. Whatever you are seeing, this is a true color composite. So wherever you are seeing green, it's an agriculture patch or a vegetation patch. Wherever white or off white, these are the open lands. This is desert on ground. This is desert on image. This is forest, basically the mangrove forest in the backwaters, and how they look on the satellite image. A portion of ocean, how it looks like. You are seeing Sri Lanka also, and the southern part of India. Snow and glacier, how they look on the satellite imagery. Okay, because snow also reflects very high on the satellite imagery. So so they also look very bright white on the satellite imagery. Then water bodies, the various lakes, ponds, rivers, they always look something like this. If they are clear water and deep water, it will look always black on the satellite imagery. If it is shallow and sediment, with sediment, it will look gray or bluish tinge on the satellite, with the bluish tinge on the satellite imagery. How a cyclone looks, this picture you people must have seen on the IMD images and all, how the eye of the cyclone is moving towards the land, and where the eye is, and how hourly basis how it is moving, and all those things. How forest fire looks like, okay, along with the fumes or the smoke which is associated with that type of fire. How a drought field on ground looks on the satellite imagery, and a flooded city. I think this is Chennai. I have some more slides on floods also. So there we will be seeing more. Okay, how canals look. See, there is a culvert. This yellow and blue things, we have done the digitization on the images. Okay, the image will be looking like this, but this blue line and this yellow line, you can actually digitize on the image, and you can say this is a canal, this is a culvert, this is the polygon which represents the canal. This is a part of the river. The white portion is basically the sand near the river. Then seeing this image, you can say it's a commercial area. Okay, you are seeing the buildings and the big roads are there. So it's some commercial area. Whereas here you can see it's a industrial area, not per se within the city, something outside the city. By seeing the these what I should say, the from the where the smoke comes, the chimneys and all. Yeah, so seeing those chimneys and the sheds which are nearby. So the contextual information is also very important in the remote sensing data interpretation. This is some garden, and then the recreation park, how it will look like. A bus terminus, you can see the parked buses and the airstrip. Okay, then some swampy area where the water logging is there, or some mangrove forest, some kind of vegetation is there with the water. It will be looking something like this. Some mud flats which are there. Then gullied land, something like your Chambal ravines and all. They will be looking something like this. Then some rocky open area will be looking something like this. Okay, so now we will go to uh, our applications. See, as far as remote sensing applications are concerned, we have the applications on the land, ocean, atmosphere, as well as the planetary. But today I will be covering only the land applications, because we have a very variety of number of applications. It was difficult to cover within this time. I'm already, I think, almost crossing the time limit. So I have few ocean applications also, but atmosphere and planetary exploration we will cover some other time. Okay, so when we talk of land applications, we have a number of satellite sensors which are there for the benefit of the people, where using the data of these sensors and satellites, we can do a number of land applications. Okay, so when we talk of land applications, we basically talk in the field of agriculture, water resources. Most important these days, the disaster, because their frequencies have increased. Then the geological applications are also being done. The mineral exploration, the applications related to the geological structures and all, a number of things can be done. Then on soil also, soil type mapping, soil degradation, which is basically linked to your land degradation and all that. Then urban related, urban process related lot of application. The town and country planning departments of the various states, they work with us for the various urban planning projects which are going on. Then forestry is one another very important area where a lot of remote sensing applications. And the rural development, the rural part of the India, where a number of developmental activities are being carried out using this kind of data. So we will quickly go through them. Okay, so first is agriculture. See, you need agriculture information. India being a agrarian in a country, it needs information at various levels. So you need information at the India level. What is the national level information, or what is the national status of our various crops? You need that level. At state level also, you need, say, for example, for Andhra Pradesh, what are the prominent districts where the rice is grown. Then at the 60-meter, then at the district level, you need what type of crops are sown within a district, something like rice and cotton. So whatever green you are seeing, that is rice, and whatever yellow you are seeing, that is the cotton. Okay, so these are the crops which are sown almost at the same time, but they have different type of reflected energy. That is why they look different on the satellite imagery. Then at the block level information, many government departments, they need information at the block level also, and obviously at the village level also they want. So to cater to all these kind of requirements, a number of satellite sensors have been sent, and they are being used at various levels. Okay, so major operational activities at an RSC, if you see, we do the projects like Fasal, NADAMS. What is Fasal? What is NADAMS? I'll be coming. Then a very interesting project of crop insurance is being done by us, by the remote sensing community. For, I can say, for the last 3 to 5 years, it's very challenging thing, and challenging area also for the agriculture people, because a lot of ministry requirement is there as far as crop insurance is. Then crop intensification, this is another area where we are working. Then agricultural drought vulnerability, that is one more area. Then horticulture estimation, area under horticulture, and how to manage the various horticulture crops. Those examples I'll be showing. Then high value crops, these are the crops which is basically the requirement from the Ministry of Commerce. They want the menthol type of crops which fetch lot of cash, which has lot of cash values. Okay, crop value means in terms of money, in monetary, this thing. So menthol is one mint or menthol mint crop, from where the menthol is extracted, and which is used in number of medicines also, and for other this thing also people use it. So for menthol mint inventory, and how much area is under that, and then obviously the economic evaluation of that crop. So that is another area where we work. Then in season crop prospect monitoring, that whether these rain fed areas, if enough rain is not there, whether a specific crop will grow or not. And then the national carbon project, how much carbon dioxide is being used by the crops. So crop rather the carbon budgeting because of the agriculture, those kind of studies are also being done. Okay, so quickly I will go through Fasal. The expansion is forecasting agricultural output using space agrometeorology and land based observation. See, I'll not take more time, but I have to tell few things which are very important. Government of India came to us some 20 years back, or at least 15 years back, and told that on two basic crops, the wheat and rice, which are the major two crops at that time. I'm telling, it was more than 20 years, not 15 years, where government wants to know how much area is sown under these two crops. And another important parameter, that how much area is sown, and not only the area, at some interval you need to give that area. Okay, so so we started giving the area estimation for uh, wheat crop in the Rabi season and rice crop in the Kharif season. Wheat crop, it started with the states like Punjab, Haryana, Rajasthan, Madhya Pradesh, UP, Bihar, yeah, these many. Okay, so with these states we started, some 5 or 6 states I told now. Whereas for rice, it was 13 states, because that is the one of the major crops of India. So West Bengal was also there, then Tamil Nadu was there, Karnataka was there. So many states were, Chhattisgarh, Jharkhand. So many states were there, including Bihar, UP, and Odisha, so many states. So it started with 2 crops. So we developed the technology that whether we can do using remote sensing data. It was not only the remote sensing data, it was also the ground information which was collected by those states. So the state government officials also used to come to our centers. They used to sit with us during the analysis. They used to provide the ground truth information. Ground truth information means what? That this taluka, this panchayat, this group of villages, in this area, there is a prominent rice crop. This much area is within rice. These are the areas which are new to rice, but they are being sown in this. So we used to give every, I think, 3 weekly forecast to government. Okay, because government has to use this information at various levels of planning, whether they have to import these things, or they have to plan for export. They have to plan for the storage of these things also, no? These cereal crops and the other fiber crops and so many other things. So for so many of such type of policy level issues, they needed this kind of information. So it started with 2 crops only, but now the 9 major crops. Okay, see, in addition to rice, wheat, cotton has also come, sugar cane, tur dal, that rapeseed and mustard, jute, rabi pulses, rabi sorghum. Sorghum means those fodder type of crops they sow. So all these things at the state level, at the district level, we are giving the forecast to the agriculture ministry before the harvest takes place, and again at various levels means when the sowing has taken place, after the crop is visible on the image. See, as soon as you sow the crop, you will not be able to appreciate or see it on the image. After 15 days, or for some crops after 1 month or 1.5 months, you will be able to see the signature of crop on the satellite data. So using that, and so every time wise, we give those estimates, area estimates. So started with 2 crops and only area estimates, but now we are giving 9 crops with yield estimation also. Yield means the dana part of the crop. Okay, so this much yield of this crop uh, in so much lakh hectare of area is sown, and this much is the yield. So area as well as the yield. Yield is basically area multiplied with the productivity. Okay, so it will give you the how much is the how much is the yield of that crop in a particular area. So yield is not calculated just on the basis of the area only. You need yield models to fit on these area estimates, as well as you need a lot of meteorological parameters, the precipitation, the temperature data. For rice, temperature is very important, humidity data is very important, precipitation, rainfall data is very important. For wheat, the again temperature data is, because when the wheat, when that the dana wheat ka aata hai, and then when the dough formation starts, na, at that time you need little less temperature. So when that less temperature thing has happened, when that tillering has happened, when that crop has reached its senescence, how much is the yield, all those things can be estimated using the satellite remote sensing data. Okay, so now 20 forecasts in a year at the national, state and district level is being given. And you see, the best beauty of this project is more than 90 partner institutions, where the state governments are also there, where the state remote sensing departments are also there. In Jharkhand also we have a center, the state remote sensing center of Jharkhand. In Bihar also we have. Majority of states have state remote sensing center. So all those state remote sensing center, then the Ministry of Agriculture and Farmer Welfare, then various ISRO centers. See, Hyderabad one center is there, Ahmedabad one center is there, Dehradun one center is where the application takes place. Other centers we have different other things, but these three are the centers which do a lot of application. Then IMD is also part of this, and now we have a center which has uh, 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 which is basically a center of the Ministry of Agriculture, which takes care of all these things, all the operational products of it, but which is known as the Mahalanobis Center for Crop Forecasting. Okay. So I have few slides from them also. I'll be showing that. Okay. Then next important thing is the
Excuse me, ma'am.
Yeah.
Ma'am, what about the northeastern states? Do they also have their own state remote sensing?
Excuse me, please
yes.
drop your questions in chat box. We will take the questions after the talk.
Okay, let me answer this. Just let me answer this. Yes, we have a Northeast Space Applications Center in Umyam. Okay, so that is also there, and which takes care of all the state, plus the state agriculture, plus the state agriculture departments take care of the agriculture. Yeah, what is it? Yeah, plus the state agriculture department and the other state departments also. Okay, so they also join with us, say when we were doing this rice wala cheese thing na, that time West Bengal was not having that state center. It came afterwards. So there the one jute research center or something like that is there in Kolkata. They used to come and take care in this, take active role in these things. So state may not be remote sensing center per se, but some state department will be coming, horticulture department will come, and they will take part, they will sit with us, give the ground information, do the analysis with us, and give the figures of the estimates. Okay, so next application is the drought, which is the agricultural drought which we forecast, and for all the states we give the what is the scenario in this month. So starting from June to November, we will be sending these reports again to the state agriculture departments, and from there it will be going to the other departments of these states also, and in December we will be sending a consolidated. See, drought is one such thing where a lot of conflicts will be there between the state and the center. So this kind of remote sensing data becomes an evidence that yes, there was a drought, or yes, there was not a drought to the extent which was submitted by the state. Okay, so as something like as a technological evidence, this kind of data is used, and we do lot of risk map risk estimation also, then prioritization of the districts, talukas also is being done, that which are the talukas which should be given attention in the first run, then second, then third, like this, like that, so many things will be done. Okay, then for these purposes we use multiple sensors, our own sensor also, that IRS WIPS P6 also, and the two freely available American sensors are there, that NOAA AVHRR, Terra Modis, all kind of data sets will be used, because see, during the Kharif season it is the cloudy monsoon season. There may be clouds, you can see in these images, na, full it is a lot of clouds are there. Okay, so we in such scenarios where the cloud is very high, 95%, 80%, like that, we may not be able to use the optical data. Then in that case, we will use the microwave data. Okay, I'll show you some microwave this thing also. So multiple data sets will be used, and this drought scenarios and the drought reports to all the state governments will be sent. Okay, now we come to one most, what I should say, interesting part of remote sensing, which is being used these days on the crop insurance. Okay, so all of you know very well that there is a Pradhan Mantri Fasal Bima Yojana. Okay, the mandate of which is to give, to take care of the uh, uh, those crops which are having which have gone which have problem because either because of the say some this thing has happened, what I should say, some stress is there, what drought is there, or water stress is there, or which has happened due to some disaster. Okay, or some kind of problem has happened and the yield is below the desired one. Okay, so then in that case, what a farmer will do? So for that purpose, Pradhan Mantri Bima Yojana has been put. Okay, now here lot of problems were there. Okay, now what problems can be? I want to give you some small this thing on especially this thing, so that you people can appreciate how these images are being used. First thing is, how much see, a farmer is doing the insurance of its land for say x hectares. Okay, but it is the damage to the crop is only say x minus a hectare, but it is he or she is claiming the claim for the full of the earth. Okay, so government doesn't go to every field and cannot check every data. There will be a conflict between the insurance companies and the government and the farmer which is there. Okay, so we come in between in these three parties and to settle the conflicts. Now how we can help? First thing is that really whether there is a problem on land. First thing is that whether some disaster has happened, one say a hailstorm has happened, or some that वो टिड्डी दल आता है ना, वो आकर के पूरा crop को खराब कर देता है, whether such kind of event has taken. So first we will see those things, then we will see what is the condition of the crop. Say for example some very heavy rainfall was there, the crop is submerged or something like that, then we will estimate the damage to the crop using the remote sensing data and other ground data also. Okay, so then we will give a clear picture that okay, this much damage is there, but this much part of the crop is untouched because of that damage. Okay, so first thing is that. Then second is how to say that yield is less. Unless you do a crop cutting experiment, you cut the crop, you count the or rather you measure the yield of the crop, and then you say okay, instead of this much, it has the farmer has got this much only. Okay, now here also one conflict comes. Farmer wants that only that part of the area should be selected where the crop damage is there. Okay, or some area where the generally every year good crop is not there, but we have to select it in such a way that it should cover different type of growth of the crop. ओके, जहां अच्छी फसल है वो एरिया भी, जहां खराब है वो एरिया भी, जहां इंटरमीडिएट है वो एरिया भी. ओके, सो इन दिस crop cutting experiment also we use statistics, we use stratified random sampling approach. That okay, for a village, it is not basically not a farmer based, it is village based or panchayat based, like a group of villages, that these villages are affected. Okay, so we will go there and we will take those stratified random sampling approach से निकाले हुए those sites, and we will do the crop cutting experiment in those sites only. Okay, we will not go and do where the people want us to do. Okay, so it's a fair, I can say it's a fair estimation. Okay, then we will come back and you will use the satellite data. Using satellite data also we will calculate the yield. Okay, so then we will give the final figure to government that yes, this much is the yield and this much less is the yield from the previous years. See, yield you cannot calculate in a year ना. इस साल बहुत अच्छी बारिश हुई तो मेरे गांव की और ग्रुप ऑफ गांव की yield बहुत अच्छी होगी. अगले 3 साल बहुत खराब बारिश हुई, ड्राउट रहा, तो बहुत स्कार्सिटी ऑफ वाटर ही रहा. तो एग्रीकल्चर ड्राउट होगा, हाइड्रोलॉजिकल ड्राउट भी होगा। तो उन सब केसेस में सेटल करने के लिए as a technological output these images are being used. Okay, then uh, 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 see, for a state, these all the districts, now there are a number of companies, insurance companies, some 10-12 companies are there. Now every company cannot get all the districts, so we have to group the districts and give to the companies. Now again, if I'm an insurance company wala, I will go and select those districts where there is no problem. So and another insurance wala will remain with the bad districts only, okay, which is always has some problem, always yield is led or something like that. Then also the remote sensing products come very useful. What we will do, we will again take multiple year data. We will see how is the growth of the crop. So we will make a bunch of districts which are known as clusters. So say a state has some 20 districts. So we will make 4 clusters of 5 districts each, where good districts are also there, bad districts are also there, intermediate districts are also there. So this grouping we will do using the historical data. Okay, so this district has the problem of having this kind of problem. So we will take 3 districts. Okay, we will give 1 district each in each group, like that. Okay, so there also this kind of remote sensing data set comes. Now another problem I have discussed with our agriculture people, and they have told me that now what happens. See, nobody is bad, but it happens. Huh? A farmer will come, he will, or a group of villagers will come, and they will say that we have grown rice in this area. Okay, and see, my yield is very poor, so give me insurance ka money. Okay, then we will also check whether this soil is good for rice growth or not. Okay, so that kind of soil related studies can also be conducted. So that area is not suitable for rice, but still the farmer is growing. Why he should grow some other things which is suitable for that area, but by growing that he can claim the insurance money. So to settle those kind of fake claims also, this kind of data is used. Then another problem is coming, which maybe some of you might be knowing. See, many states are becoming a part of this crop insurance. Majority of states, I should say. But the settlement is in few states only. Okay, so the states which have more, what I should say, takatwar states like Rajasthan, Maharashtra, the farmers are able to hold the people in their group of villages where they can say, no, 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 मेरा तो crop खराब हो गया है, मुझे तो पैसा मिलना चाहिए, और आप देखिए ये खराब है, ये खराब है, ये खराब है. Now the premium is given by all the states, but the benefit is getting to some 4-5 states only. This is also happening. Okay, so many states like Bihar and all, they want to come out of this insurance thing. Why? Because they feel that they are only paying the payment, paying the premium, whereas some other states are always taking benefit of this insurance claim. Okay. So such kind of mischievous or fake activities also keep happening to solve all such kind of conflicts. Okay, whether genuine, whether because of the climatic conditions. इस साल बहुत बारिश हुई, सच में उसका खेत पूरा बह गया है. So then in that kind of, it's a genuine. Maybe 10 साल से वहाँ ऐसा कभी नहीं हुआ, but 11वें साल हुआ है. So what you will do? You will not give. So to settle such kind of conflicting claims, remote sensing data is very, very useful, and we are nowhere between giving the insurance money to the villagers, and no, we are only providing the technological support to settle these things, to apply the technology for betterment of the people. Okay, so I am already very late. I think Dr. Manoj will be thinking not to call madam next time. She's taking a lot of time. Okay, so this is a decision-based support system which has been formed, where you will feed all the data sets, and it will be on the right side. You can see it will using the map mobile applications also. People will be going to the various villages, to the fields, and giving you the health status of the various crops also, whether and clicking the pictures also, so that you have an evidence. No, on this date this was the status. So like that, many things are joined together, so that a fair system or an approach can be used which gives the correct picture which is on the ground or whatever has happened. Okay, the other thing is, they use lot of data sets. On the right side you are seeing a lot of data sets they are used. They even use what are the hazard mapping predictions for a particular district in a state. Then what are the drought vulnerability parameters for a state or for a district. Then they will use all these things, take into account all these things along with the data, and they will give the scenarios that yes, in these districts one can go ahead, in these districts there could be a problem. So many scenarios are being used. Okay, now the other application is crop intensification. Crop intensification is the example I am showing for the Jharkhand state only. Okay, so here basically how many types the crop is being taken, whether only during the Kharif time they are taking the crop, or during Rabi and Zaid also. So if it is only one crop per year, it is 100%. If it is two crops, 200%. Three crops. So that also helps the government for many policy making issues, as well as for the state to know that from the single crop scenario, they can go to double crop depending on the suitability of the soil, suitability of the other parameters which help in taking the crop. Okay, so this study is also known as Kharif fallows. So after the Kharif crop, whether fallows have been, whether the land has been left as fallow, which can be used for Rabi crop or other pulses. So this is one of the studies which is done using the various types. Then there is another program which is known as Chamman. Basically, it is the coordinated horticulture assessment and management using the geoinformation. Okay. Here, basically, the various horticulture crops, the citrus crop, the oil palm, mango, then chili, then tomato, even onion also is a kind of horticulture crops. The estimation of the area, because these are the crops which have very good value, cost value is very high. So, and it gives a very good return to the farmers also. Okay, these horticulture plantations. So estimating the area under these crops and how different they are. So you can see that even though they look very similar on the this resource sat image, list 4 multispectral image, but you can see the type of the crop when it is seen on the panchromatic image, it gives you a very clear picture that this is mango and this is the oil palm. So to tell this is mango and this is oil palm, you have to go once to the ground, and then multiple years you can do using the various classification approach to classify your data, that this much area is within mango, this much area is within this type of crop. And this is a very useful information again for the ministry purpose. This is a project of the Ministry of Agriculture and Farmers Welfare. Then other horticulture crops, the banana in Tirunelveli in Tamil Nadu, chili in Prakasham, Andhra Pradesh, citrus in Mehsana, Gujarat, then mango, then onion, tomato in Raisin MP. So different types of horticulture crop which fetch very good return. Then another application in agriculture is the jute fiber crop information system, where basically the jute and cotton crop information system, that and here you can see not only the ISRO, but other centers also, that Mahalob is National Crop Forecasting Center, which is a center of Ministry of Agriculture at Delhi. They, Jute Corporation of India, Ministry of Textile, and National Jute Board, they all are the participants of this exercise, and we all do it together, and we can give the inventory of the crop as well as the condition of the crop. Say how much is the crop which is waterlogged and whether some disease has happened or drought affected crop is there or something like that. So that kind of information is can also be. Then disaster. Just a minute, please. So on the disaster damage and assessment also, we have a number of applications. Then forest, I told you, but I will not go into detail. Okay. Then in water resources, we have a very good number of studies on the snow melt runoff forecasting, inventory of the glacier. I will come directly to the examples part of it. Okay, these are the applications. I'll be sharing these slides with Dr. Manoj. He can give it to share it with you people. So you can see the surface water resources and how they change every month. That kind of inventory can be done. Okay, now we have a Bhuvan geo portal where the all this information is freely available to any citizen of India. Okay, you can just type Bhuvan and you will get this geo portal, and you can get all this information what we are discussing, the various projects on this portal. So you can see that water body information system is also there, that how the water body level of in a reservoir is changing with every 15 days or something like that. So those kind of information is very, very useful for the various ministries, also for the central water body commission also. So many central so many departments of various other ministries also use this kind of thing, even for flood estimation and all. This kind of studies is used. Okay, then this is reservoir capacity loss, how much the loss is there over the years and over the months also. Okay. Then there is a program Namami Gange. You people must be knowing about that. So we are also a part of that. Here we are basically studying the sediment loss from the river Ganga and how it is changing with the plans of the ministry, and what are the changes which are happening. Okay, so basically the sediment changes which are happening. Okay, next we have the irrigated potential utilization. For irrigation, how the water is used and what is the yield of those crops. Okay, then irrigated crop monitoring also. Then we have monitoring and evaluation of the development process. Some development activity has been done this area. So how the changes have happened. So such kind of thing. Then irrigation water management, before irrigation and post irrigation, how the changes have happened. Then water logging and salinity, what is the area which is prone where it has happened, and over if some measure has taken place to stop it, then how the changes have happened. Okay, so then tank irrigation, how much water is taken, and then multiple year data will be used to understand how much is the irrigation capacity of this tank. Okay, then disaster management also, I told you people that we give lot of disaster means floods, cyclones, forest fire, landslides, earthquake, and soon for tsunami we have another dedicated center. So tsunami we are not taking care, but other things we are taking care. Okay, so flood mapping and monitoring is one aspect of that application. Then you can see the Chennai floods, that how much area is inundated, those things you can see. And here is the flooded area map also for the 2015 floods. Then for these cyclone Varda, how much again because of the cyclone related rains, how much low-lying area has gone into the this thing. So this all information is available on Bhuvan. You people can go through that. Okay, I'm trying to finish it little fast. Then flood inundation modeling and all. For this, you need a decadal or 3-4 decades data to understand these things. Then is snow melt runoff forecast in Himalayas. You people must be remembering that that lake burst. I think I have an example for that also. Okay, here I am trying to show you the utility of the microwave data. That here you can see all optical data, full cloud is there. Whereas in the microwave data, because it's the large wavelength data, it is able to traverse through the clouds, so you get a very clear picture of the on land, whereas the optical data is fully cloudy. Yeah, Uttarakhand floods. So here the pre-event, how was the main temple, how it was situated. Then post-event, how the water has flown and how all this nearby buildings and these structures have been destroyed and how the debris has flown. Okay, and then what all structures were there, what is intact, what has washed away, and what has partly washed. Okay, like that, this kind of study has been carried out. Then next is the this is Srinagar floods. Okay, then some images on cyclones also I have. This for the Orissa, for the state of Orissa, preparedness support also we give, that how the movement of clouds and how the cyclone is moving. So depending on that, they have to we give this information to state authorities so that they can plan for the evacuation process and all other things. Then you can see here how the water has inundated the nearby area. Then storm surge effect on uh, riverine flooding in the Baleshwar, Odisha. And this is again Chennai image. Then I come to the last part of my presentation, rural development. I will take another 5 minutes, Dr. Manoj, not more than that. See, in rural development, we do a lot of activities which are ministry requirement, which are the requirement of the ministry. All of you know very well the Mahatma Gandhi National Employment Guarantee Act scheme, na Manrega. Okay, then we have the Pradhan Mantri Gram Sichai Yojana. We have the Pradhan Mantri Gram Awas Yojana, Pradhan Mantri Krishi Vikas Yojana, Integrated Watershed Management Program. So many things from the ministries. Okay, now why they should come to us? The problems faced were that work, lot of spurious transaction. You people know that in Manrega and in other IWMP and other things also, lot of transaction, money transaction is there. So same person is claiming from Manrega fund also, same person is claiming from IWMP also. So those problems were faced by the government. Then parking of funds. We have given to one, how it has gone to other, and then whether work has been done and not. The government was not having any record of these things. Then delay in fund disbursement. Then there was not a standard procedure also for seeing that whether the work has happened on ground or not. Okay, so lack of transparency was there. So so the e-governance measures were used, and here basically we are delivering the government services where we are using the communication transactions and an integration of so many state of the art systems and services are being used. Okay, so here basically the to cater to the basically government to customer, government to business, and government to government transactions. Okay, we are coming in between and we are helping them to make it very smooth. Okay, you can and we are using basically the web GIS technologies, GPS, mobile applications, and the remote sensing satellite data. Now, what is the advantage of this? That planning and decision making is done at the same platform. Okay, so I am doing the planning and I am seeing by my planning whatever the decisions has been taken, whether they are implemented on the ground. Very time effective, very effective. You can monitor it over the time, and any false information is there, you can catch hold of it, and there is no bias in this kind of assessment. Okay, so Manrega, I'll come directly to, yeah, yeah. You see here uh, on the left side, you see these farm ponds have been made. Okay, and you see these geotags, that yellow, orange color thing. As soon as you click, all this information is again available on Bhuvan. So as soon as you click on this, you will get the detail of this thing. That yes, you get the picture also. Yes, this farm pond has been made, and it is of this much area. Who has taken the picture? Who has uploaded? So we are not as such going and taking the picture, but we are developing the mobile app and giving it to the state authorities and the block level authorities, panchayat level authorities. They will be taking this app on their mobile phones. They will be taking these pictures, noting down all the details and sending it to us, which information we will be uploading on the Bhuvan. And anybody, as a citizen, you also, as a ministry person sitting at the Ministry of Rural Development, also as a scientist sitting in NRSC, I can also check whether these works are being done correctly or not. Now there is a proof that this farm pond will get the making charges of this farm pond will only be given to one person, and only one farm pond has been made. So that the type of uniqueness has come, and a kind of accountability has come, that you know exactly this thing has happened, and this thing only one has happened, and when it has happened. And many times it happens that in the floods and all, these structures get washed away also, so you know the present situation on ground also. Okay, so like this, you can see all over India how many geotags have been done. Okay, for Geo Manrega, state-wise, you can see how many. So all those assets which have been made under this Geo Manrega scheme have been geotagged. That means we have added a location information to these things with the status of the asset, and a picture of the asset. Okay, and all so many other details also. So these many geotags have been done. These have been modeled. See, a senior authority has to see them and check them and say, yes, this is a asset which has been made under this program. Okay, and some of them after moderation may be accepted, some of them may not be accepted, may be spurious. So you see, 0.24 are rejected also. Okay, so with this method, government is able to, ministry is able to see that whether this activity has happened or not. If it has happened, it has affected how much, and whether the money transaction is correct or not, that they can use this data to infer that. So this is the Bhuvan portal. On this kind of information is available. All of you can see. Yeah, this is the proof of implementation, that before this Manrega scheme was there, the situation on ground was like this. Now, after Manrega, these farm ponds were made. Okay. Now these farm ponds, after geotagging, they will look that yes, this farm pond has, now you see here. This farm ponds, they don't have geotag. That means they are not made because of the Manrega funds. They are because of something else. Okay. Now these are the farm ponds because of the Manrega fund. So like that you can see, and also you can see the changes because of this farm pond. How many area is irrigated in the non-monsoon seasons? Like that, those kind of studies also we carry out. So see, it is not only the farm pond, it is so many projects. Government has given horticulture crops also for them to sow. So you see, before this thing has happened and after, how much change has happened, and the information. Then yeah. T naught is before this thing has happened, and T1 is after. So you can see the changes, and you can see the green cover which has increased in this area because of this farm pond. So these kind of changes also we see. This is part of Ranchi district, where before whatever was the situation, and now after this, after the Manrega assets have been made, what is the situation? Then Maharashtra. So these are these are the apps which will be which have been developed by us and given to those people, and they are using it to record all this information on ground and sending it to us, which will be uploaded on Google, and anybody can see that information. The horticulture trees on the side of the roads. Then another program by NABARD Bank, where instead of state officials, they are using the NGOs to implement it on ground. Similar type of thing, geotagging of the assets where which have been funded by the NABARD bank. Okay, then the horticulture crops which have grown after this scheme has happened. Okay, then another portal is that RKVY, Rashtriya Krishi Vikas Yojana. You see here as citizen also you can log in and you can go inside. Okay, statistics of how many geotags have been done, those things you can do. These are the assets which have been made as part of RKVY. Yeah, some ocean applications I decided, but I will skip. I will just show you what changes are there, but we will not go into detail. That's it. Thank you.
Thank you, Dr. Anjum. You have taken so much pain in explaining
Yes,
these
then I
things
have
and
taken so much
elaborate.
time.
So now may I request Dr. Preeti, if some questions are there, let the question be put in before the Anjum Matab, Dr. Anjum Matab.
Yes, sir. Some questions are there from our participants. One question is from a student. I think he asked that many times when we take pictures from satellite, because of this reflection or absorption, it may cause distortion. So how can we resolve this type of problem, distortion?
Yeah, sun glint can be one of the problems. Many times when we pass over the ocean, the sun glint you will be seeing on the satellite imagery, but in the next pass you may not see. Okay, so see, it is not a single pass. Na? Every 5 days or every 10 days we are taking the pass. So, and the sun glint or problem because of the reflection will be in a portion of the image. So if it doesn't cover your study area, you can still take that data and you can do the analysis. So as such, it doesn't have any, should not give any problem. But yes, if shadows are there, some areas will always remain in shadow. So then there a technique is used. Say for example, an ascending path satellite is going. So we will take another set of pictures where it is in the descending mode. But provided it's a active sensor, then only ascending and descending modes will be possible. Na? Otherwise, in passive sensors, it is only the descending mode. So in taking a pair of ascending and descending passes, you can reduce the effect of shadows. Yeah.
Okay, next question, madam.
Okay, one more questions. If in order to view original view of Earth's surface, which type of electromagnetic waves are used? You have discussed about true band, red band, or something, true color, false color in one slide. I think.
Yeah. So basically, we get multispectral data. Okay. So you can, depending on your choice of data, you can use, but never a single band is studied as such. Okay. Always we use a combination of bands because a target may be reflecting in one spectral band and absorbing in another. So only taking the reflective properties may not be useful. We will take reflective as well as absorptive as well as some different kind of interaction with the object, club them together and use it. So always FCC gives you more information rather than a single band or a true color composite also.
Okay.
Thank you, ma'am.
Okay, thank you, Dr. Anjum Matab, for a nice presentation. And we have taken 2 questions. And if many more questions are there, we'll send to you, and we'll get the answer.
Yeah.
Now, may I request Dr. Preeti Minj, if sir have joined, and then please introduce the sir, and we'll start the next lecture. Dr. Preeti.
Sir is there, I think.
Sir, Dr. Manoj, I am already listening.
Okay, sir. Okay, sir. Dr. Preeti, please introduce the sir, and we will start the next lecture.
Okay, thank you, sir. So good afternoon once again, everyone. I am going to introduce our next speaker. So our next speaker is Professor Anil Kumar Nirala from Department of Physics, IIT ISM Dhanbad. He was former HOD of Department of Physics, IIT ISM Dhanbad. He did his master and PhD degree from IIT Delhi. Professor Nirala has 25 years of experience in teaching and research. His specialization is in spectral metrology, interferometry, and holography. And recently, he is working in the field of holographic optical elements, interferometry, and biomedical optics. He has more than 50 international publications, and he guided 7 PhD students and recently guiding 3 PhD students. So today he is going to deliver a talk on 3D imaging. So I request Professor Nirala to deliver his talk. Screen share stop karna. Sir, please.
Okay, Dr. Manoj, please share my this thing. Can I share my screen?
Yes, sir.
Yes. Dr. Anjum is leaving. Then you can share, sir. Yes, you can share, sir. Now you can share, sir.
लीव करना आपको हाँ नहीं लीव ना हाँ नहीं लीव मत करो.
So can you see this?
Yes.
नहीं
Yes, sir. Your slide is visible now.
Okay. So I thank Dr. Manoj and Dr. Preeti for giving me opportunity to talk on 3-dimensional imaging. Now remember, this is not very focused talk like Dr. Anjuman Mehtab has given. This is very general talk actually, and to be honest enough, I'm working in holography, and most of the talks are basically I have basically tried to assemble things which are very general and especially the student centric. Okay, so before much ado, I'll start the talk because already it's very late. Okay, so this is the 3-dimensional imaging, and as it moves, I'll go on explaining about these things. So first of all, what is this 3-dimensional imaging? So most camera you have used the camera to capture the images and normally capture 2D scenes. And 2D images feel less natural than if we were there. Like it appears like we have only a shallow covering of the scene. Viewers of these images lose out on the realism of the scene, because why do they lose realism? Because in most of the cases they require to have the actual picture, and if you want to have the actual picture, you have to have 3-dimensional imaging. Depth is the most important aspect of the 3D photography that we'll discuss why depth is more important. And the 3D imaging is created by normally by taking 2 shots of the same scene, which we call stereoscopy also, where one is little offset to the another, and then both the scenes be merged to the to as a single scene. And this slight difference basically is enough to trick your brain into thinking that you are looking at an image with depth. That is the 3-dimensional imaging. Now, let us try to see this 3 small pictures that I have given here, and basically that tells you a little difference, not too much difference, that the 2D photography basically appears to be instant frozen time, and this 3D pictures is a way to capture some living moments. And although this is still, you can have interactive 3D also, okay, but this, you see this, the picture you have here, a cube, when you see in the 2D case, here is the height and the length, where you see in the 3D height, length, and the width. And what happens is, in the 2D, the width information is lost. Similarly, you see the image of a ball, you see that this appears to be circle, and you see this, from this you appear like you have a 2D image and you see the 3D image, how nicely they look like. Okay.
3D image.
Yeah. So now we will go basically starting from the old classical techniques of getting
3D image.
and then we'll come to the current techniques. So this is the analog 3D photography. That was basically the older techniques. And this is the 3D stereoscopic image using the camera with 2 or more lenses. I'll show you the camera. Basically what happens in this case is that you take the two image from the different angles of the same object and then merge through the optical systems into a single image. Then what happens is, because of this, we will be able to see the depth difference. And this, it uses the stereo view to create the 3D impressions. Actually, somebody is writing with the pen. So can you take care of this? Somebody writing with the pen. Hello, sir.
Yes. Please, someone is writing. Please don't do that. Someone is writing on the screen.
So sometimes this is also known as 3D scanning, and the basically camera uses and the light to capture the shape of the appearance of the real objects. And what is basically be captured is the shape, that is the geometry, and the appearance, that is the surface view. And if you capture both the two, then both of this, then you get the final result, which is richly detailed models. Now you see this is the older, very old camera, and most of the things you will see that this is why you have these four different lenses. In most of the cases, in order to have the stereoscopic image, we have 2, but in order to make it richer, we have in this case 3D. And this is basically, this is the old one, which was very famous during his time. So old, okay, 1920s to 50s, during that time. So Nimslo 3D 35mm stereo camera, which allows 3D photographs to be viewed without glass using the lenticular printing. Actually, the lenticular printing is basically a special class of printing that depending on the time that will come. But let us go to the 3D imaging stereoscopy. That this technique is to create 3D image to enhance the depth of illusion of depth in an image by means of stereopsis technique. And this is the most stereoscopic method. Still somebody writing, Dr. Manoj, please take care of this. So most stereoscopic method present
Mr. Abhishek Raj, please clear your screen.
By left, separately for the left eye for the one image, and for the right eye for the another B image of the same object, and then you basically merge both of the images. These 2 images are combined so that the brain gives the interpretation of our perception of the 3D image. Okay. Now, what are the systems? That is the older system that I'm talking about, that basically you to see the 3D images. So anaglyph is the one technique. Polarization video is the another technique. The active shutter video is another technique. Now, here I want to clarify, there are a large number of techniques, the older techniques that were available, but only few of them I'll discuss because the time that has been allotted to me, and I understand, is only 40 minutes plus minus some time. Okay. So anaglyph 3D images that we'll try to understand is basically, this is a stereoscopic 3D effect, and this is achieved by encoding for each eye, okay, the 2 different colors, red and cyan. So you have this using the filters of 2 different colors. So when viewed through color-coded anaglyph glasses, that I will show you the glasses, each of the 2 images reaches its eye that is intended for. So whatever is the red intended for this eye, that reaches to this eye, and the cyan that was intended for the left eye, that reaches to right eye. And when both of them be sit together, the visual cortex of the brain basically gives the perception of the 3-dimensional image. So this anaglyph images basically have in recent times becomes very important because of the video on the web that you see, the CDs, and even in the printing. And one of the most example of this anaglyph 3D imaging is that from the NASA, which included in the Mars rover, and that you could see that the 2D imaging, they have basically able to depict the 3D imaging. And the solar investigations also called a stereo, which uses the orbital vehicles to obtain the 3D imaging of the sun. So this is anaglyph technique. We have this is a video, not very good because this is copied from the internet. You see this, the original video. Okay, this is the original 2D imaging, and this anaglyph using the red and cyan colors you can see. So from 2D to 3D conversions, and this is the person that is watching anaglyph movie, and you see this the red and the cyan, both the colors that is having as aspects to watch that. Now this is another technique, that is the polarized 3D systems, that uses the polarized glasses to create the illusion of three-dimensional imaging. Okay, and what is done in this case is that the two images are projected, that is superimposed on the screen. Okay, on they display through the different polarizing filters, and the viewers wear the sunglass or the eyeglass, which contains a pair of different polarizing filters. So you have the two glasses, and one is having polarization coming in vertical direction, another is having polarization in the horizontal direction. Okay, so what happens is that when they allow the light to pass to the one eye, they allow only one polarization to pass on the blocks the another polarization light, and similarly for the another eye. So basically, these two, when they are basically seen together, they gives the impression of three-dimensional scenes. Okay, so this is basically with this polarized 3D systems, you can have this, many people can view at the same time. And I'll show you the video. You see here, this is the scene that is shown on the TV. This is very old, and you see this, these are the interlaced rows. Okay, this is the first rows. This is having one type of circular polarization. The second row, you're having another type of circular polarization. Third row, you're having a first type, and then another row, fourth row, having another type. So these two, the blue colors having one type of polarization, and this red colors, this is having another type of polarization. So, okay, and here is the specs that you can see. So one type of polarization is allowed to pass through the one, another type of polarization is passed through the another eye, whereas this cannot pass through this eye. That's how you have the specs. This is polarization sensitive specs, and using this, you can easily able to see. This gives the three-dimensional effect of the images. Okay, so similarly, this is depicted here, that this is the projector, and this is both right-handed and left-handed supply polarized light images is coming, but you have the specs which allows only one circular polarized to pass through only one eye and blocks for this eye, whereas with this another supply polarized light passes and blocks with that, and therefore when both of this we see together, we see the combined effect of the three-dimensionality. And yet another technique, which is the active shutter three-dimensional technique. Basically, this is also a stereoscopic technique that I have already told. And this presents the basically the image that is recorded. This is basically allows to go to only one eye, whereas blocking for the another eye. So if the same,
excuse me sir, excuse me, Dr. Anil सर एक बार स्क्रीन शेयर को हटा के फिर से शेयर कीजिए, तो ये जो लिखा हुआ है वो हट जाएगा. एक बार स्क्रीन शेयर हटा के फिर से एक बार शेयर कीजिए.
अच्छा सर, स्टॉप शेयर. Okay, so the active three-dimensional system that I was discussing. Okay, so this is the active shutter. Basically, that shutter allows the one image to pass to one eye, whereas blocking for the another eyes, and similarly for the both the cases. And when you see the together, we see the three-dimensional effect. Okay, and this is basically this type of effect is very popular these days, and because this is used in the most of the theaters that you might have seen the 3D movies, and this can be used to present in the 3D image in the CRTs, or the plasmas, or LCD projectors, and so on and so forth. Now let us see this. This is the one depictions that you can see this, that when you see with the one eye, you have this different color. This has been shown in the slow motion that you can see. With one eye, you can see the one picture. With another eye, you can see another picture. But when this is very fast, you can see a three-dimensional effect of the object. Now that in line of this three-dimensional imaging, very important two imaging techniques that I will be discussing, that two in very short, is basically CAT and MRIs, and these two techniques are very useful for most of us. Okay, so what is the CAT and what is the basic philosophy behind this CAT, and that's all. That I will not go into much detail because this one topic itself requires a lot of time to discuss. So the computer-aided tomography basically requires high energy laser beam, okay, to pass through the most of the soft materials in the human body, like our skin easily passes but blocks the bone. Okay, so depending upon the energy of the X-ray that you have, the conventional X-ray is basically the shadow. When you see when you shine an X-ray over a human body, what you will see is the silhouette. That is basically the image, whole of the image, and you can see the bone range, silhouettes of the bone that you can see, because it is stopped, absorbed by the bone, whereas it passes through most of the part of our body. So basically, this shadow gives you the incomplete information of the object. That I will show you how it gives the incomplete information. And in order to get the complete information, what has to be done so that we can get the complete information using this computer-aided tomography. Now, in this case, that imagine that you are holding a pineapple in one hand, and whereas banana in another hand. Here you can see. So it's a lady. She is holding a pineapple, okay, near to her chest, and banana in another hand, okay, and this she has stretched the hand. Now, two bulbs are there. This is the depicted. So when this bulb is there, and when we see only images, I'm not saying that when you see the object, because you say analysis through the images, okay. So when we see the image, when you see this image, when this bulb is on, what we see that lady is holding only banana. Whereas if we see this image here on the screen, what we see that lady is holding only pineapple. Okay, but none of them is complete, as you understand. So how they will complete when you see both the images? Okay, in the same way, if you want to understand that if you want to see the complete part of our body, how we have to see? We have to see the images of the body from different angles, from different projections. That's what you call. And here is the, okay, again it is somebody writing. So in the same case, you have this, the X-ray basically machine, that is, if you see that in the conventional, this uses the conventional X-ray imaging. If a large bone is directed between the or kept between the X-ray and the smaller bones, what will happen? Smaller bone will not be seen. Okay. So now, in order to see the smaller bone, you would have to hold your body. Either you have to turn your body or move X-ray machine. That's how we have basically discussed few minutes back. So like in this case, so if you want to see the whole, either you turn the object or you turn the machine. Okay, so that then you can see both the images together. Okay, so that's what it is writing. So that is the basic idea of the computer-aided tomography. What we do in computer-aided tomography machine is that X-ray beam moves all around the patient. I'll show you the picture. Okay, and the scanning from 100 of different angles, and then the corresponding images are taken, and all those images basically are stitched together to form the three-dimensional image of the body. Hopefully you understand the principle. So you see this, here is basically the depiction of the modern MRI, and here is the object that human body is lying, and here is that MRI machine that you can see. Okay, so in this case, say for example, when X-ray is emitted from here, just opposite side is basically the detector. Similarly, X-ray is emitted from here, opposite side is the detector. X-ray emitted from here, opposite side is the detector, like that. And all of them are rotating. So what they do, basically they take images from different projections, and therefore they are able to see different parts of the body. Hopefully you understand what is the basics of the MRI. Okay, this CAT. Okay, so sorry, this is slight mistake. Now we go to the MRI, the magnetic resonance imaging. Now in this case, what we see, what is the MRI? Basically, it is a scan that uses the magnetic field and the radio waves. Both the magnetic wave field and the radio wave they use to produce the detailed image of the body's soft tissue and the bones. Okay, those both are identical type of techniques, the CAT and the MRI. And basically, then how MRI works? That's the first. And why do we require MRI? All these questions I will be answering in short. So the human body is made up of billions of atoms. We all know that. Mostly the water. Okay, the fundamental building block of all the matters. Nucleus of all the atoms spin. Here is the nucleus spin. This is pieces around the magnetic field. Okay, around the magnetic field. So what happens is, now basically we are basically concerned with only the hydrogen atom. Why? Because this is the ideal atom, because it has a nucleus that is having a single proton and having a large magnetic moment. When this is why this is important. for our case, that then the magnetic moment means that when we place in the magnetic field, the hydrogen atom has a strong tendency to line up along the direction of the magnetic field. So we have the large magnetic moment, and when you keep it in the magnetic, along the magnetic direction, it will line up along the magnetic field. That is the important. So when we keep the inside the bore of the scanner, the magnetic field runs like inside the bore you have, so magnetic field runs along that bore, so either up or either down. So the straight way down to the center of the tube in which we place the patient. This means that if the patient is lying on her back or his back in the scanner, the hydrogen atom in his body will line up in the direction of either feet or head. Okay, and therefore what will happen? The mass majority of these protons will cancel out each other because they are moving in the opposite directions. But only a couple of the photons, basically out of those millions, will not cancel out. So that we can see it. See this, they are moving in opposite directions. But see here, if I say depictions, maybe 5, maybe here 6. So only maybe a few may not cancel out. And that's basically very important for us. So the magnetic field lines up along the both the north and south, and a few of them are unmatched. So what do we do with that? When the radio frequency is applied, this unmatched atom spins in the opposite directions. So the one which is unmatched, and when the radio frequency is turned off, the unmatched atom returns to the normal positions, emitting the energy. So that they emit the energy, and this emitted energy basically it sends as a signal to the computer, and the computer then uses a mathematical formula and the other algorithm to convert the signals into the image. Basically what happens is we focus at a particular point in the body where we guess that there can be something, and basically we are able to do the imaging of very small part of the body through the MRI. That's the beauty of the MRI. You see this, the machine PET and MRI machine is there. You see here the object is there, and these are basically all those things are there. The magnets, very high magnets is there. All those things I'm not going to discuss because this is basically examining the brain where the Alzheimer's disease or epilepsy or the brain tumors are present. All of you might have seen. So what is the advantage? Then why do your doctor order an MRI? That is the point. Basically, so if you want to see something inside the body, how do we see? It's the only way to cut it open. But we cannot do that with the human being. Okay, so we can see very small region of the body only through the MRI. That's the importance of the MRI. And so what is the use of the advantage of the MRI? That see small tumors maybe in the pituitary gland of the brain, which is not easy to cut open, or the infections in the brain, spine or joints, maybe the shoulder injuries, tendonitis, or maybe in the legs, mass, then you have the bone tumors, crest, and so forth. So and so many things are very important and very specialized and basically deep interior of the body that you can see only through the MRI. But there is certain advantages, like those who are having pacemakers, they cannot be done. Basically, they have it creates a lot of humming noise. Basically, that is a serious problem, and you require to have very long time basically to get MRI done. Otherwise, there will be some issue if you go on moving. Okay, and there may be some artifacts that above all it is little expensive. So what is the CAT scan versus MRI? That is the difference. So basically the idea is that CAT scan uses the X-ray to produce image, maybe little harmful, not very harmful, but little harmful, whereas the MRI uses powerful magnetic field and the radio frequency to produce the detailed pictures of the organs. Okay, so that's what I told you, do not use. The MRI provides more detailed information about the inner organs, especially the soft tissues, which you cannot get through the CAT scan, such as the brain, skeleton, or reproductive systems and other organs. Okay. Now CT scans are quick, painless, and non-invasive. That's the important. That if you want to have save time, the CT scan you can go through if you know the localized problem. So MRI basically is non-invasive, but we say having very strong noise is there. Okay, and therefore there is another problem that is basically claustrophobia, that is anxieties because of you are enclosed in this space and having a lot of sound. That is another type of image. That is one of the disadvantages. So MRI scans is costlier than the CT scans, and basically MRI causes a lot of another issues due to the very strong magnets. Now let us go to the another technique, which is the the holographic technique to see the three-dimensional object. And what is the holography that I will be discussing in this case? In just wait a minute. Just I'm switching out time. Yeah. Basically, we have seen our photographs. Okay, it's a two-dimensional image. We have this. If it is cut, okay, or a part of this is destroyed, we cannot recover it. Okay, but what is our actual object? Our actual, say for example, our face we have. So nose is front and the eye is inside. So basically, we need to have a depth imaging. And how can you have the depth of the image in the two-dimensional space, which is the, say for example, this palm is having X and Y. There is no Z in this case. So that we have to understand that. So what is the hologram? Is basically the record of the interference between the light which is scattered from an object and correlated reference wave, which is known as hologram. That I will be discussing. Basically, it's a recording, total recording, and this is difference from the hologram and the photography is that say recording of the amplitude and phases. And here we will discuss why do we require phase in this case. This is also known as reconstruction technique. But when you basically do the optical processing using the camera, when we produce simple image using the camera, then you use the conventional geometrical rays or the ray models. Whereas when you use the holographic imaging to explain the holographic imaging, you require diffraction or interference. So that's the basic difference. Now in photography, what do? We illuminate the object with a beam. So when then object reflects the light, and the different part of the object will have the different reflection coefficient. Okay, so the light reflected from the different part will have the different intensities. Okay, and we keep the basically the camera or the film in front of that. We expose it. So what we see, so apart from the amplitude variation that we have, we will also have the phase variation. How do we have the phase variation? Say for example, if you want to take the photograph of my face and you expose my face, illuminate my face with the light and keep a film here or the camera, okay, in front of this. So the light reaching from my face, that is nose to the camera, will travel a smaller distance, whereas the light reaching from my ear or eyes will take more time. They will travel more distance. And therefore, there is a phase difference between these two lights, okay, or the light that is reflected from this. So you require basically the light that is reflected from any object is having both amplitude variation and the phase variation. Why it should be X and Y? Because the reflection from the different part of the object, because of the surface property is different, they will have the different amplitude, and basically the phase that is getting reflected from the different part will have the different phase because they will reach to the image plane at different by traveling the different length. So we do need to have both amplitude and phases together in the case of the ordinary photography. Then we will understand the hologram. Now this or this, either take plus or take minus, it doesn't matter. But in case of ordinary photography, what do? We record the intensity of the image. So what do? So intensity, that means this is the amplitude. So this is the square of this. When you take the square of this and the complex conjugate of this, you multiply. So this and the complex conjugate of this, when you multiply this e to the power minus I pi, that will be cancelled. So you get the A square. So what do we see in this case? That even if we have the phase information, that could have given you the three-dimensionality, okay? But by chance, when you are capturing the image, you lost that information. See this in photography, we lost the phase information. So the light that was reflected from the object, it is not the case that was not having the phase information, but by chance, we have the detector, say for example, photographic film on the camera, which is basically the square law detector. And that square law detector is unable to detect this phase part. And that is why we are unable to get the phase. And so we are unable to get the three-dimensional image of the object. Okay. So if you want to have the three-dimensional image, you cannot have just on the surface. Okay. You can have somewhere in the space. Only then you will have, because the depth is also required. Okay. So the question now is, then how to get the three-dimensional image? That is the question. In most of the cases, all the detectors that basically, including our eyes, they are the square law detector. they have no capacity to record a phase. So they cannot record phase, but still there is way out. And basically, then how do we record the phase? We transform the phase, okay, into the intensity variation, and then we record it. Okay, that's let us try to understand then how do we record the three-dimensional image of an object. Here is the underlying principle of the hologram. So if you want to record this three-dimensional image of this cube, say for example, okay, and here is the holographic plate, or maybe the camera you can have, doesn't matter. So holographic plate or simple roll film that we were having in the ancient time. So we need to have one mirror here. And in this case, in case of photography, we use normal light. But in this case, what we require is a coherent beam, maybe from the sodium vapor or from a laser source, okay, or many other type of sources are there, available there. So both this coherent beam basically will illuminate with the object with this coherent beam, and at the same time the mirror. So what will happen? The light that is reflected from the mirror, that will also come to this holographic plate or the roll film, and at the same time that is reflected from the object, that will also come to the holographic plate. Now remember, in case of hologram, the light that is reflected is basically not useful. That basically gives the noise. Again, somebody is drawing that. Okay, so in this case, what we see is that the light that is scattered from the object, which reaches to the holographic plate, and the light that is reflected from the mirror, which reaches the holographic plate, these two objects, when they interfere, that we have the recording of that. Now, we will show you in the subsequent sections that how just by putting a mirror, we are able to record the phase, and therefore the three-dimensional image of this cube. All right. So what we record in this case, in the holographic film, holographic plate is, or in this plane is, that this light, which has no height variations, you see, but where in this case, that this is kept here. So different portions, this side, they are having the height variations. So this light, when this light reaches here, they will have the different path lengths, and therefore different phases, and this will have the no phase variations. So this light which is coming from the mirror, that we call the reference beam, whereas the light that is coming from the object, that we call the object beam. Okay, so this is the object actually written here. So what we do is we do the recording of these two beams, okay, through this holographic plate, which is the same roll film, just backing is the glass plate. Now let us see this, try to understand this through the very short few lines equations only. So this is the object wave. So this is the object beam that we are discussing. So the object beam again is having amplitude and the phase part. Okay, and again the reference beam is having the amplitude and the phase part, but definitely they will have the different phase and the different amplitude. Okay, so these two are basically reaching to the holographic plane. So they are interfered. That means they are superimposing each other. Okay, so once we have to add it, and then this is the amplitude, and what do we record is nothing but the intensity. So we have to square this. So once we have added and square it, we get this term. So this OX by and RX by, and in place of O, these are the terms. So AX by e to the power I phi, and this is the BX by e to the power I psi. Okay, so this, and when we square it, squaring means multiplying this quantity with its complex conjugate. So this quantity we have multiplied with the complex conjugate. Okay, so complex conjugate means if this is imaginary, it will change the sign. So here we have the imaginary quantity. Here we have imaginary quantity. These are the real quantity, the real amplitude. Okay, so these will have the different sign. So like here I have written in this case. So in this case, X and Y I have removed here from X and Y. Okay, so that I have removed here, and so B like this, and this term, that complex conjugate that I have applied. So A e to the power minus I phi plus B to the power minus I psi. Okay, and then we have multiplied these two terms. So A star e to the power I phi and e to the power minus I phi. So that is cancelled. So e to the power 0. And similarly, we have multiplied all the terms. This with this term. So again, the phase term is cancelled. Now this with this term and this with this term, you see that. So these are the four terms we get. So this is what we are recorded. Once we record this on the plate, holographic plate, and we process it, that means we develop and fix, then that we call the hologram. So we have basically recording, that is what we have written, that the first step we have done the recording. So this is the recording that we have done. Okay, this is the recording that we have done. Now the second part is the reconstruction. Reconstruction means you'll see this here. We have done the recording, and when we'll reconstruct, that means this is now hologram after processing, okay, developing and fixing. Now we will remove the object and we will illuminate the object with the reference beam. So now we are trying to see what is there recorded in this case. Okay, that is the reconstruction. All right. So this is the case that we have to see it. That we'll explain it in the subsequent slide. So reconstruction means illuminating with the reference beam. So once we illuminate, this is the hologram with the reference beam. What we see is the two images: the virtual image that was at the place of where it was kept, and another image which is real image, which is dim and which is having virtual image in the high intensity. But when you want to reconstruct this with complex conjugate of that beam, either complex conjugate of this beam is this, or you can either rotate it, spin it, okay, or flip it. In either way you can do it. You can get these real and virtual images, they are interchanged. So reconstruction by the conjugate beam, whereas the reconstruction by the reference beam. Both the cases we will try to understand. But before we understand, we will plot the amplitude transmittance versus the exposure here. Okay, so this is the, what is the amplitude transmittance? The amplitude transmittance is the amplitude, basically the ratio of the amplitude wave, the emergent amplitude divided by the incident amplitude. That is the amplitude transmittance. And the exposure, you know that, the intensity into the time. So that I have been plotted. And what we see in this graph, that here is, this is known as here is the linear region of the curve. So if we select the transmittance and the exposure in such a way that it falls in this region, then what will happen? The T will be proportional to exposure. And the exposure is basically intensity into time. So the T will be proportional to the intensity. So that we will see that T is proportional to the intensity. And if we choose the proportionality constant as 1, then basically whatever is the intensity is in amplitude intensity that has been recorded, basically we will get the same as the transmitted. So this is basically the same as the transmitted. So once we illuminate it, now what we do is, in order to basically reconstruct the hologram that has been recorded, we illuminate with the reference beam. This is the reference beam. This is the reference beam. Okay. So this is the reference beam. So this has been basically recorded. Now this we are illuminating with the reference beam. Somebody is writing something, sir. Manoj, hello.
I'm looking after that, sir. I'm trying to solve it.
So okay. So this is the reference beam, and this is the reference beam that we use. Basically, this is the reference beam that we have. Okay. So we are trying to reconstruct with the reference beam. Okay, this is the reference beam. So this is the recorded one. So this is the multiplied with case, and here is the, so T is this, and B is e to the power I pi. So when we multiply this with this, that means this is a square plus b square b to the power I pi, and when we multiply this with this, the minus 5 plus 5 term will be cancelled, and we multiply with this will become twice. Okay, so this we are writing at the same. Now in this case, what we are doing is leaving this b square term, and then the a e to the power 5 we are writing, okay, together. And in this case, b square that I am writing, this is the same as this, but here this term has been written like this. So b square and a e to the power minus I5 to the power star, that means a to the power I5, because this is the, when you take the complex conjugate, a to the power minus I5, it becomes like this, and this e to the power twice I5 has been left. So what do we see? That when we illuminate the recorded hologram with the reference beam, this reference beam, we get the 3 terms, 1, 2, and 3, and we have to understand all these 3 terms one by one. So the first term basically is the, what we see, that the constant intensity, okay, that is basically, which is little distorted. That means we'll see here that when we illuminate this is the first term that is going. So 2 more terms we are having. So we'll see the 2 more terms. This is the second term, and what we see that this e to the power I pi, this is the object. This is second term is proportional to the object a to the power a into e to the power I pi. That means the second term gives you the complete information of the object. That's the beauty of this holographic technique. Whereas this terms, and that means that is viewing this, the effect of viewing this will be the object itself. That is, all the essential features of the object, such as depth, will be produced in this case. So whatever you have been seeing the object, say for example, the face, the nose is front, the eye is inside, all those depth information, because the complete information in this case you can see amplitude and the phases. Whereas in case of the photography, we lost this phase information. Whereas in this case, the second term gives you the complete information, amplitude and the phases. Okay, and the third term basically gives you the same, but this is a complex conjugate of that. That means the complex conjugate is that will be basically with the distortion, because distortion is the phase terms. Okay, so what we see now. Okay, so we see that this is the first term. The second term is this virtual image. So complete information about the object. We have the depth perception, and this is the real image. Again, the complete information, but this is the distorted. So this will be of the same size as that of object, but this will be of the slightly different side, not exactly same side as that of the object, and this will be dim. Okay, it's very difficult to see that. Manojji.
Yes, sir. Yes, sir. We are trying to solve it, sir, but some students are doing very bad thing.
Okay, I'll finish fast. Don't worry. Don't worry. Already madam has taken a lot of time, and so very little time is left. Now, when we illuminate the same hologram with the reference wave, conjugate reference wave. Earlier we told that it's a reference wave, but now conjugate reference wave, we'll get almost the same term, but these two terms will be interchanged. Okay, so what is the virtual image and what is the real image? In this case, that we have to see that. So virtual image is this, that this is the virtual image. That means the virtual image, basically we will see the try to understand the virtual image is. Basically, that virtual image is the, if you process the hologram that is placed back in the original reference beam, both these original beams and the replica of the object, both we get the virtual image and the real image. Now, if we look along the reconstructed object beam, what we see is the replica of the object beam as well as the shifted viewpoints. So when we see, when our shift the angle of viewing like this or up and down, we will see the different perspective of the image, the sides and parts and so on and so forth. So this is basically we'll see the complete perspective of the image, which is the three-dimensional orthoscopic image. So what we see in this case is a complete three-dimensional image through the holographic technique. So all the depth perception we will be seeing complete. So it's a very different from the photographic image. And with this also we will be seeing this with little difference that we'll have. Okay, this is the virtual image, but with the real image that we call the pseudoscopic image. Now remember, this is the real, but it is pseudoscopic. Now don't think like real is the pseudo image. This is not the pseudo image. This is the pseudoscopic image. Please try to understand this. That means why it is pseudoscope? There is a depth inversion that is taking place. Okay, that we'll understand in the following slides. That why depth inversion is taking place. What was near to the observer that has gone away from the observer, and what was away to the observer that has gone near to the observer. That is what we call the pseudoscopic image. And pseudoscopic image, basically, if you want to do any measurement, scientific measurement based on the three-dimensional holographic technique, then with the real image, you will face the problem. So the question is, what is the solution of this? So the same thing, it has been depicted. Okay. So now the two things that has been basically told in this case, what is flipping and spinning? So that I can tell you here, it's a better way to understand this. So basically the flipping is you keep the upside down. So if you have this image holographic plate, you keep this upside down, that is flipping. Okay, so what will happen? The upside of the image, the head of the image will go down. But the spinning means you have to rotate it by 180. That is the spinning. Okay, so this is both the things you can apply depending upon that which one you want to see brighter and which one you want to see with the less intensity. Okay, so those flipping and spinning that has been explained in this case. Okay, so now here is very clear that this is the recording, and now you do the reconstruction, and here is the observer. So what you see is this type of recording was done because this is a two-dimensional image has been shown of the cube. So this was the recording that was in front of the observer. This was the virtual image. And this is the real image when you see. the front side has gone away from the observer. This is the front side. So what we observer is seeing the back side, and therefore real image is the pseudoscopic image. That's the importance of this. But once we understand that the real image is pseudoscopic image, then definitely it sounds something like unusual to us. That why we want to have the real image, which should be orthoscopic image, not the pseudoscopic image. So virtual image should be the pseudoscopic image. Okay, but this is the case that you are getting. Okay, so the question is how to get real orthoscopic image. That is the orthoscopic real image that has been discussed in this slide. So this is that there are two ways to do this. The one is that if you want to have the real pseudoscopic image, real orthoscopic image of this bucket, then you have to use a lens. This is the one-step technique. Illuminate the object, this bucket, and the image this using the lens. This image will be here. Now, before the image, you put a holographic plate, and they are the reference plate. You process it, and then you will get the real in this case, orthoscopic real image, not the pseudoscopic real image. Or there are ways, another way to do it, but that is basically the two-step holographic technique, which is relatively easy to understand this. Now, this is the first hologram. Now, we'll try to understand the same thing in a symbolic representation. So, this is the reference beam that we have, and we want to record the image of this bucket. This is the object now. So, we will illuminate the object with the laser light. So, the light will go along the all directions. So, whatever is the scattered light that reaches the holographic plate, and the reference light, it also goes to this. So, the interference of both is recorded. After it is processed, that means developed and fixed, what we get is the hologram that we call the H1 hologram. Okay, so now the H1 hologram we are trying to basically reconstruct. So what we'll do, we'll use the reconstruction wave in this case, not the object wave. So once we do the reconstruction wave, what we'll see, we'll get the two images. One where the already object was there, that is the virtual image, which is the orthoscopic that we have shown in the earlier case. And the another case, the another image we'll get is the real pseudoscopic image. The third one is this light that is going straight. Now in this case, we call one step recording we have done. Now this real pseudoscopic image we will use as an object. Why? Because this is a real, that means light is coming. So light is exactly reaching. So whatever the light reaches here, that I have shown here. So again, this is the real orthoscopic image, that light is there, and we add the reference beam. And the interference of these two are recorded on the holographic plate. Okay. So whatever we get in this case, the second stage, this is another hologram. Now, but in this case, the real, basically the object is basically the real pseudoscopic image, because this is a pseudoscopic image, and so this is the reconstruction now. So when we reconstruct with the reference beam here, what we see, it was here we'll see the virtual image, but this time this will become pseudoscopic, and here we'll see the real image, and this time it will become orthoscopic. Hopefully you understand that. Okay. And with this, these are the applications of three-dimensional imaging. Not many applications: 3D conferencing, medical fields, product design, marketing, science and technology, 3D gems, simulations, display, designs, presentation of the microscopic stereographic images, 3D models are in architecture, in animations, and so on and so forth. Now let us try to have this anaglyph image, one of the video that you can see, that how can you basically, it's a one-dimensional image, and how can you give the pseudo three-dimensional depth that you can see through this anaglyph image. And this is very beautiful that you can see. This is the actual object, and you see that you can see the three-dimensional image. Okay, and let us see now the another here. We see basically the holographic that I have discussed in this case. This is the actually holographic plate that you are seeing this. And when you illuminate this with the reference beam, depending upon the type of hologram that you have, either you can have this, say for example, we have the ordinary hologram, and we have both the color hologram also we have in the lab. Okay, so now depending upon this, we can see this, that how we will be able to see the three-dimensional image of this. So depending upon the complete perspective of the image, you can see, okay, of this object in this case. Okay, whereas in the photography, you will be seeing this on the surface, whereas in this case, what we see, that this holographic plate basically appears to have a memory. Okay, when you see the holographic plate directly without illuminating with the light, what you will see that there is no image recorded on that. Whatever is there, well, you see the very small lines. But when you illuminate with the reconstruction beam, those lights diffract. Basically, those lines diffract the light, and then image is formed. That's what we have to understand it. So I'm repeating that when you see the recording on the photographic plate using a high resolution microscope, you won't be able to see the image. In fact, image is not available there. Okay, when you do the reconstruction, okay, then through the diffraction, image is formed at that time. Okay, and that you can see through the video, the image is getting formed. Okay, so that's all. This short presentation. Thank you.
Thank you, Dr. Anil. There was some hindrance because of some unwanted thing that happened during the presentation. But I would like to ask Preeti ma'am if there is some question. Please, madam.
No, sir, there is no question.
Actually, it is very
Okay,
late.
then. No problem, sir. Thanks a lot, sir, for taking for such a beautiful presentation. And I would like to say Dr. Preeti Minj to give vote of thanks.
Once again, good evening to all. I feel that today we have had extremely useful day. We have learned and gained so much from our speakers. I really hope that all our listeners are benefited by this webinar. So first and foremost, I thank our speaker, Dr. Anjum Mehtab, scientist, SD, NRSC, ISRO, Hyderabad. We are very pleased that you have given time for us, and you have given very informative and talk about remote sensing and briefly discuss its application, especially on land and agriculture. And I also express my heartfelt thanks to Dr. Anil Kumar Nirala, IIT ISM Dhanbad. Although he was very busy, but today he is with us. The talk he delivered on 3D imaging is really interesting and informative. I would like to thank our organizers, Dr. S.C. Gupta, President IAPT, and Dr. Manoj Kumar, Secretary IAPT, for organizing this interesting and useful webinar. And I thank all the IAPT members for their support and guidance. I'm also thankful to faculty members and students of Physics Department, Central University, Jharkhand. They have prepared posters of webinar and generate the registration link for this. And I thank Dr. Mridula Prasad for her constant support during our preparations. She helped us to solve our technical issues. Because of her support, we have successfully conducted our webinar. I am thankful to those who directly or indirectly help us to organize this webinar. And thanks to all faculty members, students, teachers who have joined us in great numbers, not only from our college, but also from other colleges of Ranchi University, from JVM Family School, from Central University, Jharkhand, from BIT Mesra, from St. Xavier's College, Gosner College, and many more. We thank you for your active participation. Once again, thank you so much to all who are present here. Thank you.
Thank you, Preeti.
Okay, thank you.
With this, this a lot of thanks to our speakers and other participants. We are ending this webinar. Thanks a lot. Keep safe. Be healthy. Thank you very much.
Thank you, sir.
Sorry.